What if the first stories were not written on stone, but carried in the cooling breath of ancient stars? What if the elements resting in every ocean, every mountain, every quiet pulse of life were once drifting embers from suns that lived long before this planet opened its eyes? Wherever you are tonight, I'm glad you're here. Settle into the slow turning of the world, into the silence that gathers at the edge of thought. Let the hours loosen, the sky dim softly, and let the earth remember for a while. Because tonight, a question rises like dust in a forgotten chamber. Did ancient stars seed this planet with the elements that would one day learn to wonder, to listen, to dream? Breathe softly. The story begins like all cosmic stories do, not with sound, but with a glow fading through unimaginable distances, and with a memory that refuses to disappear. In the earliest quiet, before oceans learned to move and before stone learned its weight, there was only dust. Not the dust of roads or rooms, not the kind that clings to shelves and forgotten corners, but the drifting remains of stars that had once burned with impossible brightness. This dust floated through a darkness that was never truly empty, a darkness thick with potential, patient, and wide like the breath between heartbeats. Each grain carried a history older than any world, a fragment of light that had fallen out of its burning cradle. Some grains held the ashes of supernovae, still trembling with the memory of collapse. Others held the softer remnants of gentler stars, those that had faded slowly, exhaling their final layers into the waiting dark. Together, these drifting particles moved through the galaxy like unwritten pages, searching for a binding. Gravity, quiet and unseen, listened. Not like a voice listens, but like a vast intention that has no beginning and no desire. It drew the dust inward with the gentlest persistence, gathering what had been scattered. Nothing rushed. Nothing tried to become anything, yet everything moved, slowly, toward the center of a forming whisper. Clouds thickened, shadows deepened, light bent with the soft weight of matter learning its first shape. Within these swirling currents, carbon met oxygen in silent proximity. Iron drifted past silicate grains like strangers sharing the same forgotten road. There was no purpose, but there was motion, and that was enough. Over uncountable ages, the drifting cloud became denser, folding into itself like a long-forgotten memory returning to the surface. The dust was no longer scattered. It began to gather warmth from its own compression. Heat returned, faint at first, then stronger, as if the ancient fires that once lived in distant stellar hearts recognized a chance to be rekindled. The cloud thickened into a disk, rotating slowly, the way a dream turns when it searches for form. At its center, light began to grow. Not sudden, not loud, just the soft insistence of energy remembering itself. Around that faint central glow, what would one day be the sun, the remaining dust clung together in delicate collisions. Grains became clusters, clusters became stones, stones became drifting worlds of rubble. Every moment of contact was an echo of earlier stars learning their last language before silence. And through these collisions, through this gentle erosion in reverse, the planet that would be called Earth began as almost nothing, a smear of material, a trembling possibility, a shadow forming in the cradle of light. Across its earliest surface, once it grew large enough to be called a surface at all, the young world was molten, a sphere of fire wrapped in darkness, spinning slowly, cooling slowly, gathering the elements that had once belonged to stars so distant they might as well have never existed. Iron sank inward, heavy with the memory of collapsed giants. Silicates drifted upward, forming the first fragile crust. And above it all, vapor swirled, water waiting to fall, carbon waiting to settle, nitrogen waiting to whisper across the sky. Nothing about these movements felt alive, yet each was a step toward life, carved from materials that had already burned in other suns, carrying within them the patterns of losses so ancient the universe had forgotten their names. The planet cooled, though cooling was not an act but a surrender. The fires beneath its forming crust dimmed to a slow pulse, a heartbeat inherited from the fusion of stars that no longer existed. And as the crust thickened, it cracked, it shifted, it bowed under the weight of its own newborn landscapes. Mountains rose and fell before they ever saw an ocean. Valleys stretched across the planet's face long before water found them. All of it shaped by dust that had drifted for billions of years, waiting for a place to land. But even then, Earth was not yet Earth. It was still a memory under construction. It had no oceans, no breath, no quiet forests dreaming their slow green dreams. Only stone, heat, and the remnants of stellar deaths repeating themselves in slow, shifting motions. Yet somewhere within that structure, buried in molten chambers or frozen into the first hard minerals, the ingredients of life waited. Carbon, restless and eager for bonds. Hydrogen, ancient and patient. Oxygen, forged in the burning hearts of stars that had never seen this world. Sulfur and phosphorus, metallic traces, grains of iron, drifting isotopes, still echoing with the last sighs of stellar fire. All of it waiting. Waiting for the planet to cool, waiting for water to fall, waiting for time to gather into something that could remember itself. The dust that had once learned to shine in the cores of distant stars had now gathered into a sphere of rock turning silently through the void. No one watched it, no mind could understand it, but the universe held it, gently, in gravity's steady hand. And through that holding, a question lingered unspoken, unfelt, yet present. What might this dust become once it finally learns its shape? The planet rotated, slow as a whispered thought, toward futures it could not yet imagine. And beneath its cooling crust, the oldest starlight waited to rise again. As the planet's surface settled into a quieter rhythm, small things gathered meaning in ways no voice could describe. The dust that had once been part of stars lay heavy in hidden places, pressed into seams and veins, folded into the planet's slow skin. In some crevice, a grain of carbon found another grain and did not pass. They clung, a private conversation of atoms. In a cooled pocket of basalt, iron arranged itself with patient intent, aligning like a memory that recognizes its shape. These were not acts of life, not yet, but they were beginnings of patterned tiny resistances to entropy that would, over unfathomable time, become the grammar of living things. The planet held them all without haste, allowing chemistry to practice its first soft experiments. Rain did not arrive at once. When it did, it fell like a slow exhale, a release of what had been trapped in vapor and sky. Each drop carried with it an encyclopedia of old fires, isotopes, trace minerals, the faint fingerprints of explosions that had once been brilliant and brief. Where a drop met rock, it did not simply wet, it conversed. Minerals dissolved and reformed, surfaces smoothed into new possibilities, and pools of water collected elements that had no names yet. Shallows became laboratories of patience, places where molecules could meet often enough to remember how to join. In these liminal spaces, under dim, patient light, the first experiments of organic chemistry unfolded with no audience and no applause. Beneath the surface, tides not yet born tugged at hidden reservoirs, drawing warm fluids through narrow channels where clay and stone cradled them. Temperature gradients whispered directions to molecules, coaxing them toward configurations that held together a little longer than before. Complexity grew like lichen on stone, slow, unassuming, unobserved. Structures formed and fell away, only to form again with a different cadence. Each fragile stability taught the next one to hold on longer, and so persistence gathered like dew on an unhurried morning. The earliest patterns were humble rings of atoms, loops of carbon, simple folds that did not yet want to become anything grand. They were small resistances to dissolution, brief moments where order outlasted chaos. Yet in their tiny continuances lay the possibility of rehearsal. Time, in its expansive generosity, allowed these rehearsals to repeat until novelty arrived by accident. A molecule that could copy parts of itself, a chain that could assemble from smaller pieces, a compartment that could trap a pocket of solution long enough for new reactions to occur. These were accidents that carried within them the signatures of ancient starlight, isotopes that remembered the cadence of explosions in their mass. The planet's chemistry thus bore the voices of stars without speaking them. Rocks kept their records quietly. Layers accumulated like pages pressed together, each one a soft map of what had passed. Sediment trapped organic fragments, dissolved metals, the residues of ephemeral chemistries. Over time, compaction and heat read these pages back into new minerals, preserving hints of previous experiments as fossils of chemistry rather than fossils of bodies. The archive of the planet was not only in bones and shells, it was in the clay, in the filamentous films along hot springs, in the crystalline lattices that bore isotopic stamps like invisible signatures. These were not stories told aloud, but they were stories nonetheless encoded in ratios, in trace elements, in the way sulfur preferred one neighbor over another. There was a kind of patience in these processes that resembles a slow music. No crescendo, only sustained tones and long, resonant overtones. Repetition became the instrument through which complexity learned to play. The planet did not hurry. It gathered repetitions until the improbable became ordinary. From many small continuities, larger structures emerged. Compartments within compartments, gradients that favored direction, cycles that returned reactants to useful states. The environment itself, temperature swings, tides, mineral surfaces acted like a teacher with no intent, offering constraints and possibilities in equal measure. Occasionally, a comet or asteroid would pass close enough to touch the planet's outer skin, leaving behind a handful of stranger elements, a different pattern of isotopes, a glittering of the other. These arrivals were gentle disturbances that expanded the chemistry's palette, adding ingredients that had not been present before. Such offerings altered local conditions subtly, nudging a set of reactions toward novel pathways. No drama accompanied these changes. The planet absorbed them like a long-breathed inhalation and continued with its quiet work. In some warm, protected niche, perhaps a tide pool warmed by sunlight, perhaps a hydrothermal cleft heated from below complexity, finally found a way to hold itself through time just long enough to matter. A structure replicated a fragment of itself. A boundary maintained a distinct interior from exterior. These occasions were tiny and unannounced, yet they pivoted the history of matter toward possibility. The starlight in their atoms hummed on, indifferent and patient, while the planet began, irresolute and slow, to host the first acts of living choreographies. All of this unfolded without thought, without guidance. It was a choreography of tendency atoms preferring certain companions, energies nudging reactions along, chance meeting repetition until the improbable learned to persist. In this soft, unflashy way, the dust that had learned to shine in distant stars gathered into systems that could begin to recall. Memory first appears as persistence, a molecule that persists through a cycle, a structure that resists dissolution, a ratio etched into stone that will outlive transient conditions. And so the planet continued to turn, its surface cooling, its chemistry rehearsing, its layers reading one another in silence. The dust that had once been fire slept now in stone and salt and water, patient as the dark between breaths. Somewhere within those patient accumulations, the first hints of recalling took shape, fragile as frost and persistent as tide. Would the next part continue to trace the slow arrangements toward the first breath of life? As the young planet rotated beneath a dimmer sun, shadows drifted across its unsettled surface like lingering thoughts searching for meaning. Nothing yet alive stirred in these shadows, but the materials that would one day breathe were already rehearsing their identities. Each atom carried a biography older than continents, older than oceans, older than the very notion of life. Hydrogen remembered the beginning of time itself. Carbon remembered the last breaths of dying stars. Nitrogen recalled the quiet forging inside long-faded stellar cores. These memories were not conscious, not chosen, only written into the weight and arrangement of each particle, held the way stone holds heat after the fire has passed. And the planet, without knowing it, gathered these memories into new harmonies. Pools of water collected across the cooling crust, neither clear nor empty. They were infusions of minerals, broths of stardust, mirrors of the sky that had not yet learned its final color. Steam rose from their edges, carrying whispers of gases newly freed from volcanic breath. In these warm shallows, water did what water always does. It coaxed structure from chaos. Molecules dissolved, rearranged, rejoined. Patterns flickered like early constellations appearing, disappearing, returning with subtle variations. Some arrangements held just long enough to invite another bond. Some dissolved immediately, their brief existence lost, except in the faint shifts they left behind. The stones below these waters shaped their own conversations. Minerals formed lattices that suggested order, surfaces that encouraged molecular gatherings. Clay, with its layered structure, trapped organic fragments between its sheets, holding them in place just long enough for new associations to form. These tiny imprisonments were not hostile, they were cradles. They allowed chance encounters to linger, to consider themselves long enough to imitate purpose. Over endless cycles of wetting and drying, heating and cooling, the cradle of clay offered a repeating rhythm, one that taught molecules how to hold, how to fold, how to persist. In deeper places, far below the tender warmth of sunlight, hydrothermal vents exhaled heat from the planet's restless interior. Their mineral-rich plumes billowed through the ancient oceans, creating gradients of temperature and chemistry. These gradients were invitations for complexity. Where hot and cold met, reactions shifted direction. Where minerals precipitated, surfaces formed for molecules to gather. The vents were not alive, but they behaved like engines of possibility, driving cycles that persisted through seasons the planet itself had not yet learned to name. In the chimneys of these vents, tiny compartments formed from iron-sulfur minerals, creating natural reactors where organic molecules might encounter one another in new ways. No audience bore witness, yet these unseen spaces rehearsed the earliest steps toward continuity. In the quiet above, the atmosphere thickened. Gases released from the planet's interior rose and settled, mixing in currents guided only by heat and wind. Methane drifted beside nitrogen. Carbon dioxide brushed against water vapor. Lightning appeared and vanished in sudden flares, sculpting new molecules in the streaks it left behind. Each flash was a reminder that energy could carve meaning into matter. The sky was a restless chemist, shaping the ingredients that would one day assemble into living forms. Yet nothing in this process felt urgent. The planet's development resembled a long breath held between exhalations, a pause in which everything rearranged itself with patient inevitability. The crust beneath all this activity thickened into shifting plates. They moved so slowly that their motion could be mistaken for stillness. Yet the movement mattered. Each shift opened new vents, raised new mountains, submerged old landscapes. Each transformation altered the chemistry of oceans and air. The planet was editing itself, reshaping its own conditions in a continuous, unhurried cycle. These transformations were not dramatic. They were geological sighs, the kind a world makes when preparing for futures that have not yet imagined themselves. The elements within this world, carbon, nitrogen, sulfur, phosphorus, did not act alone. They traced long arcs across the planet's systems, cycling between stone, water, and gas. Each journey introduced slight changes, tiny asymmetries that accumulated into new possibilities. Carbon dissolved into water, settled into sediment, rose again in volcanic eruptions. Nitrogen was struck by lightning, pulled into molecular chains, released once more. Over time, these cycles grew more intricate, more interconnected, weaving a net of chemical relationships that spanned the entire world. This net did not yet support life, but it created the environment in which life could someday stabilize. Everything remained quiet. Not silent, the planet had never been truly silent, but quiet in the way an idea is quiet before it becomes thought. The dust that had begun this journey had transformed into stone and sea and air, yet it had not abandoned its origins. The stars were still present in every atom, their ancient pressures and temperatures encoded into the material now, drifting through oceans or sleeping within minerals. The planet itself had become a vessel for starlight, a place where the universe might someday remember what it once knew. And somewhere, deep within this world of water and fire, a chain of molecules folded in just the right way. Its stability lingered longer than the others. It attracted partners. It created echoes of itself. It resisted the immediate return to silence. It did not understand what it was becoming. It could not know that this small act of persistence was the first whisper of a vast lineage, the earliest rehearsal of life's unfinished song. Yet even in that moment, nothing changed quickly. The planet continued its slow rotation. Waves touched new shores. Volcanoes exhaled. Clouds drifted without language across the forming sky. And the dust that had once shone in ancient stars waited, now holding its breath inside a world preparing to dream. The young world drifted quietly through its orbit, a cooling ember suspended in a cradle of darkness. Its crust thickened, cracked, healed, and cracked again, each fracture a memory of the dust from which it formed. Beneath these shifting plates, magma pulsed like a buried heartbeat, slow and patient, carrying within its glow the remnants of stars that had burned themselves empty long before the planet existed. These molten chambers shifted minerals from one layer to another, lifting them toward the surface or pulling them deep into the mantle. Each movement carried ancient isotopes, each plume a silent messenger of forgotten stellar histories. Above this restless interior, oceans deepened. Their waters no longer shallow mirrors of the sky, they now pressed into trenches sculpted by tectonic motion. Pressure layered itself on water, and water layered itself on stone, creating a cathedral of darkness in the planet's depths. Down in those lightless expanses, minerals dissolved slowly, releasing ions into the water, like quiet thoughts drifting through an ancient mind. The chemistry of these depths was not still. It was a slow, unbroken negotiation between the ocean and the rocks it touched. Hydrogen sulfide seeped from cracks in the crust. Iron ions waited in suspension. Carbon dioxide dissolved into equilibrium, only to be disturbed again by the faint rise of a new volcanic plume. Near the surface, sunlight weak through the planet's young atmosphere scattered across the waves. It warmed only the outermost layers of the sea, unable to reach the deeper sanctuary where complexity was rehearsing its first fragile steps. But even this shallow warmth mattered. Temperature gradients were invitations for new structures to form, for molecules to explore possibilities in their energetic restlessness. Warmth allowed certain reactions to proceed more readily. Cooling allowed others to stabilize. In this gentle oscillation, the water recorded the sky's faint rhythms. Above the oceans, the atmosphere thickened further, accumulating the gases released from the planet's inner fires. Methane traveled beside ammonia. Water vapor coiled through the currents. Volcanic ash drifted and fell, painting the sky with minerals that once glowed in stellar cores. Lightning stitched brief, bright scars across the clouds, each pulse a momentary furnace capable of forging new bonds. These sparks carved pathways through gases, assembling molecules that had never existed before. And though each one lasted only an instant, the residues they produced drifted downward through the air, settling quietly into the waters waiting below. On land, if the rugged, molten terrain could be called land at all, lava flows cooled into fragile crusts, only to fracture under their own brittleness. Each cycle of cooling and cracking added new surfaces for chemistry to explore. Rainwater collected in these fractures, forming pools rich in minerals leached from the rock. In these ephemeral basins, molecules that had formed in the atmosphere mingled with those forged deep beneath the crust. The pools dried under sunlight, concentrating their contents into thicker solutions. Then the rains returned, dissolving and redistributing what had gathered. This cycle repeated countless times, each iteration a quiet rehearsal in which molecular relationships deepened or dissolved, guided only by chance and the faint push of energy. Clay minerals formed in these pools, their layered structures expanding and contracting with each wetting and drying. Between these layers, organic molecules found shelter from the chaos of the open water. The minerals acted like guides, aligning molecules into patterns they might not have discovered alone. Some arrangements disintegrated immediately. Others persisted just long enough to influence their neighbors. Over time, these experiments accumulated, building a tapestry of trial and error across the planet's surface. In deeper waters, hydrothermal vents continued their ceaseless exhalations. Their chimneys grew taller, their mineral walls thickening with each passing year as metals precipitated from the superheated fluid. Within the labyrinthine pores of these chimneys, reactions took place in the dark. Heat drove molecules into motion. Minerals offered catalytic surfaces. Gradients of temperature and acidity created natural laboratories where organic structures could form, break, and reform. Nothing here was alive, not yet, but the environment supported a complexity that suggested the faint outline of what life would become. Amid this vast and gradual choreography, the planet's rotation guided currents across the oceans. Water carrying organic fragments drifted toward warm shores, then back into cooler depths. These currents mixed the planet's chemistry, ensuring no region remained isolated for long. Molecules formed in shallow pools were carried into deeper waters. Compounds forged near vents might find their way toward more temperate regions. Through this constant circulation, interactions multiplied and new combinations emerged. Occasionally, a meteor would brush the atmosphere, burning briefly before scattering its fragments across the surface. These visitors brought their own archives, complex organic molecules formed in the cold of interstellar space, preserved inside ancient stone. When these fragments dissolved into the oceans, they added new possibilities, new threads for the planet to weave into its growing chemical fabric. The Earth accepted these gifts without question, folding them into its slow experiments. Over millions of years, the planet's chemistry thickened like a story gaining depth. Reactions that once occurred rarely now happened with increasing frequency. Molecules that once persisted only briefly now found ways to stabilize. Patterns began to echo, and those echoes grew stronger with each repetition. In this vast, silent rehearsal, the world was learning not consciously, not purposefully, but naturally, how to sustain complexity. And through all this, the dust that had begun its journey in ancient stars remained at the heart of everything. It was in the minerals underfoot, in the molecules forming in pools, in the salts dissolving into the sea. The starlight within those atoms whispered its forgotten history through the planet's every movement. Time shaped that dust into new forms, guiding it toward the possibility of awareness. The young Earth did not yet know what it would become. It only turned, slowly, beneath a patient sky. And in its turning, complexity gathered in quiet persistence, preparing for the next subtle shift. The planet's young air carried a subtle haze, the kind that softens a horizon until distance feels like an exhalation rather than a measure. In this muted atmosphere, sunlight arrived in thin, wandering beams that warmed the ocean's surface without piercing its depths. The warmth was gentle, like a forgotten glow returning to stone. Waves lifted and fell in slow, unsteady patterns, moving minerals across shallow basins, smoothing jagged lava into softer edges. Each wave carried traces of ancient explosions, carbon washed from old volcanic remnants, nitrogen dissolved from early storms, fragments of meteor dust that had drifted for eons before settling into the water. The ocean became an archive where starlight mixed with stone, and stone mixed with memory. Along rocky shorelines, tide pools formed with every rising swell. In these pools, sunlight evaporated water during the day, concentrating molecules into thicker broths that darkened with potential. When night arrived, cooler air condensed moisture back into droplets that fell into the pools again, diluting them only to begin the cycle anew. Over thousands of such cycles, fragments of organic molecules gathered within these shallow pockets, amino acids, simple chains of carbon, small rings that held each other briefly before drifting apart. The pools did not hold life, not yet, but they practiced the motions of trial, the slow rehearsal of order seeking a foothold in dissolution. Deeper inland, the landscape itself shifted with volcanic patience. Lava plains cooled into brittle surfaces, cracked by the faint tug of gravity and the thermal breath of the planet beneath. Rainwater seeped into these cracks, carrying dissolved minerals downward. When the water met heat from below, it transformed, rising again as steam that carried new compounds to the surface. Each cycle eroded the stone, infusing the terrain with materials that had once been forged in stellar collapse. The crust became a wandering library of elements, iron waiting in seams, sulfur sleeping in pockets, phosphorus hidden in the folds of ancient rock. In the oceans, currents traced slow routes like drifting thoughts across the face of the world. These currents did not yet know their later strength or their future rhythms. They were wandering, shifting with heat and wind, carrying particles from one emerging coastline to another. With every journey, these waters mixed the Earth's scattered chemistry, ensuring that no region remained separate for long. Molecules formed in a warm pool could ride a current into colder depths. Structures forged in darkness near hydrothermal vents could drift upward towards softer temperatures. In this way, the inheritance of stars circulated through the planet's entire body. At the boundaries between hot and cold, light and dark, stillness and motion, molecules began to behave differently. Some chains grew longer than before, some folded in on themselves, creating pockets where reactions could occur in isolation. These folds were fragile, one shift in temperature, one stray ion, and they unraveled back into simpler shapes. But occasionally a fold held long enough to encounter another molecule, and then another, creating patterns that lingered. Persistence was the first whisper of memory, though the planet did not yet know what memory meant. Down in the deep ocean, where sunlight never touched, hydrothermal vents continued to exhale their mineral-rich breath. Their chimneys rose like silent monuments, coated in layers of iron and sulfur that had precipitated from the hot fluids. Within the porous walls of these chimneys, reactions unfolded in small, sheltered chambers, each no wider than a grain of sand, yet filled with gradients of heat and dissolved metals. These chambers became accidental sanctuaries for complexity. Organic molecules collected in their tiny hollows, held there by chance differences in charge or thermal flow. Some of these molecules assembled into larger structures, guided not by intention but by the shapes of the mineral surfaces that cradled them. Outside the vents, the ocean remained dark, but not empty. Dissolved organic matter, remnants of atmospheric lightning, fragments of meteor dust, products of unseen chemistry drifted in slow suspension. When currents pressed these fragments toward the vent structures, they encountered new temperatures, new minerals, new opportunities to form bonds. The deep sea was not lifeless, it was timeless, a theatre without lights, where ancient stardust rehearsed its next transformation. Far above, the sky thickened with volcanic exhalations. Ash drifted downward in fine, soft layers that settled into the sea, carrying with them metals and isotopes born in the planet's molten interior. These new materials altered the ocean's chemistry subtly, opening pathways for reactions that had been impossible before. Even the ash carried memories uranium that remembered the compression of ancient stars, thorium that held the faint signature of neutron capture processes long past. These elements carried the universe's oldest stories, settling gently into waters barely ready to listen. Through all of this, the planet remained unaware of its own becoming. It did not hurry. It did not aspire. Its processes unfolded with the same calm inevitability as erosion, as tides, as the slow cooling of stone. Complexity increased because time allowed it, because chemistry followed its tendencies, because dust from forgotten suns had arrived with a potential that simply needed the right conditions. And one day, though days were not yet measured, the first faint boundary formed. A structure enclosed a pocket of molecules, separating an inside from an outside. The boundary was fragile, easily broken by a shift in temperature or a ripple in water. Yet while it held, even for a moment, it created a space where reactions could linger together. The boundary dissolved, another formed. Over time, these brief enclosures became more common. They were still not alive, but they were closer. They were the planet's first quiet attempt at holding its chemistry in place, the earliest scaffolding for continuity. And beneath this progression, the dust from ancient stars waited patiently in every atom, carrying the memory of the universe into each new arrangement. The Earth continued its slow rotation. The oceans breathed in their tidal sleep. The land exhaled steam from its fractured crust. And something small, something fragile, something persistent was beginning to gather shape from the haze. Time on this young world behaved like a patient hand smoothing stone, slow, deliberate, erasing sharpness while gathering pattern. In sheltered inlets and beneath mineral-rich surfaces, pockets of chemistry that had once been ephemeral began to take on a different cadence. Repetitions lengthened into chains of events. Cycles folded into loops that returned not quite to their starting point, but to something slightly altered. The smallest stabilities, molecules that held together a fraction longer than their neighbors, began to bias the landscape of possibility. They invited companions, accumulated fragments, and through that accumulation produced greater persistence. This was not a leap so much as a coiling, a gathering of tiny continuities into a rope that could bear weight. Heat, humidity, mineral surfaces, and the slow tumbling of tides all conspired without intention to favour those arrangements that could survive one more cycle. Survival here was only the capacity to remain assembled through a dry spell, a cooling, a sudden influx of dilute water. It was an endurance measured in moments that, when stacked across eons, became a new measure of time. In certain liminal places, the chemistry grew stranger, not because of anything like design, but because constraint shaped possibility. Pores in iron-sulfur chimneys offered narrow corridors where molecules bumped into each other more often than chance would suggest. Clays with layered sheets provided flat plains where polymers might align. Pools that evaporated under a mild sun concentrated solutes until associations that were once improbable became routine. These environmental biases did not speak. They simply offered repeated circumstances and, in repetition, a kind of primitive memory emerged. A chain that could be templated by its surroundings would appear more often, and the environment itself, rock, water, and heat, began to act like a slow teacher, presenting the same exercise to chemistry until certain answers became familiar. Occasionally, a subtle shift would tip a local experiment into new territory. A surge of hydrothermal fluid could alter the pH of a niche, changing which bonds were favourable. A meteor's fragment might add a rare metal that catalyzed a particular reaction, opening a route previously inaccessible. Lightning flickering through the upper atmosphere could fashion new building blocks that rained gently into sheltered pools. Each perturbation was a minor punctuation in a long sentence, but sometimes these small marks redirected the rhythm enough to let new structures hold longer. Over time, the accumulation of such shifts widened the variety of chemistries the planet could host. The repertoire of possible molecular dances multiplied, and with more dances came more opportunities for a pattern to repeat and persist. Persistence began to take on a kind of economy. Arrangements that could catalyze their own formation, or that could produce environments favorable for their continuation, effectively increased their representation in local chemistry. Not intention, but amplification. When a molecule's presence made it more likely that similar molecules would form nearby, that molecule's form became a favored motif. Surface-bound reactions, those that occurred on mineral faces, were particularly effective at this because surfaces concentrate reactants and orient them in ways that free solution does not. The planet provided scaffolds. The molecules seized them, slowly but surely forging pathways of self-reinforcement. As these pathways matured, boundaries that once flashed briefly into existence became more stable. Lipid-like assemblies clung to one another, forming thin films that separated interior from exterior, however briefly. Within these tiny enclosures, concentrations could be maintained long enough for further chemistry to unfold in relative isolation. The boundary itself was not alive, only a physical constraint, but its effect was profound. Inside, interactions repeated in a small theatre, away from the relentless dilution of open water. Here, chance had a longer leash. Here, sequences of reactions could be strung together into functional chains rather than dissipating after a solitary attempt. Through countless iterations, some systems acquired a capacity that looked, from a distance, like rudimentary heredity. Molecules that could assist the formation of structures similar to themselves increased the probability that those structures would persist in the next cycle. The mechanism was crude, error-laden, and fickle, but it introduced a form of continuation across time, an echo that could be recognized in subsequent states. The planet had begun, in the gentlest manner possible, to store patterns across events. Memory, fragile and local, emerged not through intent but through repetition, constraint, and an environment that returned similar conditions again and again. All the while, the atomic signatures of ancient stars remained inscribed in every participant. Isotopic ratios and trace metals carried histories of stellar furnaces and supernovae, and those histories influenced reaction rates, bond strengths, and catalytic behaviors in ways subtle enough to escape notice, yet real enough to shape outcomes over long durations. The universe's old fires thus continued to speak, their voices embedded in mass and charge, guiding possibilities like a faint, persistent current. So the world folded its small experiments into larger patterns. Pools that once held only transient mixtures now became theatres, where sequences of chemistry could be rehearsed across cycles of wet and dry, warm and cool. Films that separated inside from outside became more frequent. Reactions that helped reproduce their own scaffolds accrued influence. The accumulation of such tendencies did not announce itself. There was no visible enlightenment, no trumpet of arrival. Instead, the planet settled into a different kind of patience, one where the unlikely became ordinary through steady repetition. And somewhere within these layered rehearsals, among films and metallurgic pores and evaporated basins touched again by gentle rains, a functional linkage endured a few cycles longer than it had any right to. It persisted through dilution and heat. It templated a similar pattern in its wake. Its presence nudged the chemistry around it toward continuation. For a moment, perhaps for many moments strung like beads, the planet hosted the echo of itself. The dust that once learned to shine had become the keeper of this echo, folded now into membranes and chains and mineral walls. The old starlight resided not only in atoms, but in the patterns those atoms made when gathered and constrained. The planet continued its slow turning, the cycles repeating, the chances stacking until, in the hush of uncountable repetitions, something resembling persistence began to hum. Would the next part trace the first fragile continuities into the threshold of living breath? When the planet cooled enough for water to fall, the rain did not arrive in storms as later ages would know them. It came as a long, unbroken sigh, millions of years of vapor gathering in the new sky before drifting downward in curtains so soft they blurred the line between air and earth. The first raindrops carried nothing of innocence. Each held the memory of its birth. Hydrogen older than galaxies, oxygen forged in the dimming hearts of stars that had once burned with impossible pride. Falling toward the warm crust, these drops met minerals still trembling with the afterglow of molten stone. Their meeting was gentle, like two forgotten stories touching at the edge of a page. As the rain continued, pools became lakes, lakes became seas, and seas deepened into the first oceans. The planet exhaled steam through its fractured crust, feeding the growing waters. Every basin filled not with simple liquid but with cosmic inheritance, dust dissolved into transparency, starlight broken into ions, heat carried from the core into swirling currents. The oceans formed slowly, not as force but as memory, gathering pieces of everything the universe had already lived through. Their depths held hydrogen from the beginning of time, oxygen from forgotten suns, trace metals from supernovae, and silicates from the planet's own bones. A world that had once been fire now learned the weight of water. These early oceans did not move with the structured rhythm of later tides. The moon had not yet settled into its long companionship with Earth, and the gravitational pull between them was still new, still uncertain. Instead of predictable cycles, the waters swayed in great uneven pulses, shifting with the planet's rotation, the winds, and the tremors from deep within the mantle. These movements were not purposeful, yet they carried patterns, slow, wandering circulations that lifted minerals from the seafloor and carried them to newborn shorelines. The oceans behaved like a vast, restless archive, rearranging its pages in silence. In the shallows near the coasts, sunlight reached into the water and warmed it, coaxing dissolved minerals into new arrangements. Iron, sulfur, and carbon drifted in shimmering clouds, each particle carrying the imprint of its stellar origin. The sunlight here was faint, filtered through an atmosphere still thick with volcanic breath, but its warmth, gentle as a whispered recollection, altered local chemistry in subtle ways. Reactions that would freeze in the deep found room to wander in the shallows. Complex molecules that formed in the air settled into the water, joining minerals that had risen from the crust. The boundary between sea and sky became a porous exchange, starlight dissolving into currents, volcanic exhalations sinking toward the seafloor. Deeper still, where the light could not follow, the water thickened with pressure and age. There, the ocean held its memories more tightly. Dissolved salts traced histories older than the planet itself, recording the temperatures at which they formed, the conditions under which they dissolved again. Even the water molecules bore silent signatures. Hydrogen atoms scraped from the fabric of the early universe, oxygen atoms shaped by stars that had died before Earth was born. In these depths, The planet carried the cosmic past like a forgotten dream sinking into sediment. Volcanic ridges on the ocean floor exhaled minerals into the water, their vents glowing faintly in the darkness. The minerals did not rise far before cooling into shimmering plumes that drifted sideways in slow, quiet billows. These plumes painted the water with gradients warm to cold, acidic to alkaline, rich to barren. The gradients were not instructions but invitations. Molecules entering them behaved differently, reacting in ways they could not elsewhere. The ocean floor became a tapestry of invisible thresholds, where chemistry shifted direction, where atoms learned new companions, where the universe rehearsed the earliest gestures that would one day shape life. Near the shores, waves eroded the first rock into grains and dust. These fragments carried the memory of the planet's heat. Basalt softened into sediment, feldspar crumbling into clays. As waves washed these minerals back into the sea, they dissolved slowly, releasing ions that drifted across the water like forgotten whispers. The oceans read these whispers without thought, folding them into their expanding body. Each grain lost to the water became part of a record far older than any fossil, a record that traced not life, but possibility, the chemistry that life would eventually require. Occasionally, the young planet shuddered. A fault beneath the seafloor opened, letting magma bloom into the water. The contact was violent for an instant, but the ocean absorbed the heat, spreading it across its vastness until the disturbance became another memory. Minerals sealed into the magma were released into the sea, adding new ingredients to the planet's silent experiments. Each eruption expanded the ocean's library of elements. Nothing was wasted. Every trace of the interior found its place in the water's growing archive. And through all of this, the oceans remained patient. Their surface reflected a sky still unsettled. Their depths carried histories so old they defied language. The water did not know what it would become. It only held, dissolved, circulated, and waited. The world had not yet taken its first breath of life. But the oceans, vast, wandering, ancient in their atoms, had already gathered everything they would need. In their depths, the dust of stars settled into silence, preparing to be transformed once more. The oceans, still young and unsettled, stretched across the planet like a slow-moving thought. Their boundaries were uncertain, their depths uneven, their colours shifting with the minerals that dissolved into them. Yet even in this early ambiguity, they carried a coherence, a softness in their movement, a gathering of ancient threads that had once drifted alone through space. What began as rain had become a world-enveloping hush, a blue veil that smoothed the planet's once fiery surface into something quieter. Beneath this veil, the earth began its long meditation, and the waters became its memory. In the first light of each pale morning, the surface of the ocean shimmered like a page of unwritten script. Sunlight fell across the water in hesitant strokes, its rays broken by clouds of volcanic ash suspended in the air. These beams were weak, filtered through layers of gases the planet had not yet learned to balance. But even their faint warmth returned meaning to the waves. The uppermost currents carried this warmth downward in slow spirals, touching minerals suspended below the surface and shifting their reactions ever so slightly. Temperature gradients blossomed like invisible tides, guiding molecules toward or away from collisions. The oceans did not sense these patterns, yet they enacted them faithfully, moving as the sky instructed, reshaping their chemistry with every sunrise. Far below, where sunlight dissolved into darkness, the water pressed heavily against the ocean floor. This pressure was not cruel. It was a kind of gravity's embrace, holding ancient atoms in place long enough for them to converse through reaction. Silica, from young volcanic rock, dissolved into the water and drifted until it found other elements with which to bind. Iron oxidized and fell as soft precipitation onto the seafloor, creating layers that recorded the ocean's breath one grain at a time. These layers became stories of temperature, stories of acidity, stories of minerals rising and falling in cycles too slow for anything but stone to witness. Over millions of years, such stories would be buried, compressed, transformed. But in these early epochs, they formed the first soft archives of a planet learning to remember. Currents wandered across the oceans in wide, looping paths. They did not yet follow the patterns set by continents, for the land masses were not fully formed. Instead, They swirled freely, guided only by the planet's rotation and the uneven heating of water by the sky above and the crust below. These currents carried with them dissolved gases, carbon dioxide from the atmosphere, nitrogen from volcanic exhalations, traces of noble gases from the planet's formation. As they moved, they delivered these ingredients into pockets of ocean, where reactions waited quietly for a nudge. Every journey a current made contributed to the planet's growing chemistry, spreading the legacy of stars across every corner of the sea. In shallower regions, where basaltic coastlines met the water, waves eroded rock into fine particles that drifted outward. These sediments carried metals and minerals that influenced the ocean's behavior in subtle ways. Phosphorus dissolved from stone and mingled with calcium drifting from deeper vents. Sodium and chloride combined into salts that thickened the water's character. If the earth could have listened, it would have heard the quiet sound of dissolution, a whispering exchange between stone and sea, shaping the planet's future with every grain lost to the waves. Sometimes the water withdrew, not in tides, as known later, but in long, slow fluctuations caused by shifts in the volcanic ridges beneath it. When the sea pulled back, shallow pools remained, warmed by the sun and concentrated by evaporation. In these basins, organic molecules left by atmospheric lightning gathered in faint films along the stone. Each time the water returned, it dissolved those films and carried them outward, scattering them into the broader currents. These cycles repeated countless times, sharpening the ocean's chemistry like a blade honed on stone, giving form to the earliest whispers of complexity. In the depths, hydrothermal vents breathed minerals into the water with steady determination. Their plumes rose in dark, shimmering clouds, rich with metals, sulfur compounds, and trace elements older than the planet itself. As these plumes cooled, their contents precipitated into the surrounding water, creating gradients that served as quiet engines of transformation. These gradients were the closest the early Earth came to direction, warm meeting cold, rich meeting poor, acidic merging with alkaline. At each intersection, molecules behaved differently, folding or unfolding, dissolving or forming, imagining new shapes in their momentary collisions. Above all this, the oceans reflected a sky that had not yet decided its palette. Sometimes it glowed a pale, hazy blue. Sometimes it darkened under the shadow of volcanic ash. At times it blushed faintly with the scattering of ancient sunlight. Whatever its mood, the sky always returned its reflections to the water, and the water held them gently, as if afraid they might shatter. Through reflection, the oceans learned the early language of light, not through photosynthesis, which had not yet begun, but through warmth and colour, through the subtle encouragement of photons touching molecules suspended between clarity and depth. Occasionally, meteors fell into the water, dissolving or sinking into sediment. Their fragments brought new chemistries, new isotopes shaped in the cold of interstellar space. These interstellar visitors did not disturb the ocean's tranquility. They simply extended the archive. The water accepted them in silence, adding their stardust to its growing library. And so the oceans deepened not only in volume, but in meaning. They became the planet's most patient historian, recording every trace of starlight, every whisper of stone, every shift in the sky. Nothing alive swam through them yet, but the ingredients of life wandered their depths, searching for the conditions that would allow them to linger together long enough to matter. The oceans did not know what they held. They only remembered, and their memories grew deeper with every passing age. The oceans, now vast and wandering, stretched their weight across the young planet like a soft, endless exhalation. Their touch shaped the world with patience rather than force, smoothing mountains that had barely formed, dissolving minerals that had cooled only recently from molten origins. Every shoreline trembled under the slow, deliberate pulse of the waves, as though the earth itself were learning to breathe. And beneath that surface, beneath the rolling skin of water, something deeper unfolded, an inheritance being sorted, layer by layer, into currents, sediments, and shimmering clouds of dissolved memory. In the pale light of early mornings, the water carried a translucence that belied its depth. The uppermost layers were thin veils compared to the fathomless darkness below, yet they held the planet's first experiments in warmth. Sunlight, fragile and filtered through an atmosphere heavy with volcanic vapor, reached only a shallow region of the sea. But wherever it touched, molecules stirred differently. Water warmed. Minerals shifted into new configurations. Simple organic compounds, drifting without purpose, found themselves guided by faint currents shaped by day and night. These early interactions were small, almost ephemeral, but they introduced the first irregularities, the rhythmic expansions and contractions that hinted at cycles the planet would one day take for granted. Beneath the surface shimmer, where the light dissolved into a deepening quiet, the water held temperatures that changed only slowly. These depths were ancient, even though time had not yet gathered enough events to measure itself properly. Here, pressure smoothed motion into something gentle. Molecules encountered one another with fewer interruptions, fewer distractions from heat or wind. Dissolved gases behaved differently in this calm darkness. Carbon dioxide formed weak bonds with water molecules, creating delicate chains that drifted like ghostly threads. Hydrogen sulfide lingered in pockets near volcanic ridges, waiting for minerals to catch it. Trace metals precipitated from cooling plumes and settled onto the seafloor in layers too fine to see, yet thick enough to reshape the water above them over ages. This deep ocean was not empty, it was contemplative. Every element within it had a story older than the planet itself, and those stories shaped the chemistry that was unfolding. Hydrogen, with its ancient origin in the first moments after the universe began expanding, moved through the water with a kind of lightness, a reluctance to bind unless conditions were just right. Oxygen, newer but forged in the quiet torture of stellar cores, was more eager, forming bonds with metals, forming minerals, forming structures that hinted at future complexity. Even the salts with their sodium from ancient rocks and chlorine that remembered interstellar ice were storytellers, dissolving and recombining in ways that softened the planet's early chemistry. Near the ocean floor, heat seeped upward from fractures in the crust, creating narrow columns where water rushed from cold to hot in a matter of centimeters. These gradients were invisible but powerful. They created tiny worlds, each with its own rules, its own preferences. In some places, the heat was enough to break apart molecules drifting too close. In others, the warmth coaxed reactions to proceed that would otherwise be frozen in stillness. Molecular chains elongated and folded. Charged particles aligned along mineral surfaces. Even the simplest ions found that their behavior changed with each shift in temperature or pH. It was as though the ocean floor was offering countless invitations for new structures to form. The minerals exhaled by hydrothermal vents added richness to these environments. Iron, nickel, sulfur, all were released into the surrounding water like quiet offerings. When these minerals cooled and precipitated, they formed delicate chimneys, porous and intricate, filled with tiny chambers where molecules might linger longer than usual. These chambers created isolation, and isolation created possibilities. Organic fragments drifting into these spaces encountered conditions that differed from the open sea: lower dilution, higher concentration, more frequent interactions. The planet did not intend these laboratories. It simply allowed them to form, and chemistry followed. Closer to the coasts, the ocean behaved differently. Waves ground stone into sand, and sand into silt, and silt into particles so fine they seemed to float even after the water carried them far from shore. Clay minerals formed in these sediments, their thin sheets absorbing and releasing water with every shift of tide or rain. These clays became surfaces of memory, capturing organic molecules between their layers, holding them long enough for reactions to occur that would be impossible in the open sea. Each drying event concentrated the contents of a shallow pool. Each rainfall rehydrated the film left behind. Over countless cycles, these pools rehearsed structures that could hold information, even if only in the most fragile form. The ocean listened to these rehearsals without understanding them. Its currents swept the results outward, dispersing them across the water column. Some fragments dissolved immediately, others persisted, carried by wandering streams to regions where temperatures or minerals shifted their fates. The sea did not discriminate. It only remembered through sediment, through solution, through the slow accumulation of reactions repeated across ages. Occasionally, comets or meteors fell through the sky and touched the water, dissolving in bursts of steam and mineral. Their debris added organic molecules that had formed in the cold dark of interstellar space, compounds shaped by ultraviolet light from stars long dead. These arrivals enriched the ocean's memory, mixing ancient cosmic chemistry with the planet's growing internal archive. Nothing in these deliveries suggested life, but they broadened the ocean's vocabulary, giving it new ways to test the boundaries of possibility. Each evening, as the sun dipped below the rim of the horizon, the surface layers cooled and sank. Warmer water rose to replace them, stirring the upper ocean in slow spirals. These motions carried oxygen from the air downward, carried dissolved minerals upward, and distributed organic molecules across zones of temperature and pressure. These circulations, so simple in their mechanics, allowed distant chemistries to meet, to compare, to merge. They wove the planet's earliest experiments together in a soft, wordless dialogue. And through all this movement, all this dissolving and recombining, the oceans deepened their character. They became not merely the planet's water, but its memory, an ancient archive of starlight and stone learning to speak in chemistry. No life yet drifted through their depths. But life's shadow, life's echo, life's first faint potential had begun to take shape in their silence. In the vastness that had become the sea, memory layered itself like sediment, thin, incremental, almost invisible until the weight of accumulated ages bent the page. Currents braided one another, forming long, patient highways that carried dissolved fragments from equator to pole, from shallow shelf to abyssal plain. Along these highways, chemistry practiced the art of repetition. Molecules met, separated, met again with slight differences. Each encounter left a trace, a changed bond here, a missing atom there that shifted probabilities just enough to nudge subsequent meetings toward new outcomes. This slow, marginal drift was not design, but a quiet selection by circumstance. Those formations that could endure the tide's dilution, that could reassemble after being sheared apart by turbulence, that could resist the slow scavenging of mineral surfaces, became proportionally commoner. In this way, endurance itself began to sculpt the ocean's library. Persistence accrued as if time were a patient editor, folding successful sentences back into a longer story. Beneath the fair skin of waves, where light thinned and pressure grew, layers of precipitate gathered on the seafloor like the slow handwriting of the planet. Iron-rich mats spread outward from vents, their filaments trapping particles that drifted by. Silica sank in glassy sheets, smothering older deposits and capturing within them the chemistry of a vanished moment. Each buried layer sealed a whisper, the temperature of formation, the trace elements present, the acidity of the surroundings. These whispers, when read by future stone, would speak of environments that had long since dissolved into other states. For now, they remained a private record, the ocean's own memory keepers stashed in darkness where light could not blur them. Where shallow shelves sloped into deeper basins, gradients formed like invisible fences. Salinity shifted, temperature dropped. Chemical potential slid along these slopes, coaxing reactions to occur in narrow bands. In such bands, concentrations rose slightly higher than in the open water, offering a marginal increase in the chance that complex assemblies would form. In these narrow theatres, molecules that might otherwise succumb to diffusion found a stage to persist longer, fold in new ways, and perhaps link into sequences with nascent functionality. The ocean, in its spatial eccentricities, provided countless such niches, small theatres, where continuity could hold for an extra breath. Storms, though infrequent by later standards, left marks on this memory. When wind carved the sea into white-capped unrest, currents shifted, sediments resuspended, and previously buried compounds swirled back into the active column. These disturbances acted like erasers and scribes at once, some records smudged, others newly written in the churn. After the storm's sigh, the ocean settled, carrying with it a slightly altered distribution of molecules. In this manner, the planet's episodic violence became part of its long pedagogy, occasional force introducing variability that repetition alone could never achieve. The chemistry of life's precursors was not universal across the oceans. Pockets existed where conditions favoured polymerization, others where hydrolysis dominated, others still where metal catalysts amplified certain linkages. These pockets were not static. They shifted with currents, with volcanic exhalations, with the slow drift of plates below. The ocean's heterogeneity thus became its teacher. Diversity of conditions allowed more experiments to run in parallel, increasing the chance that one arrangement, somewhere, would persist long enough to begin transmitting its form into the next cycle. Diversity, in this case, was an engine of possibility rather than mere coincidence. Tiny films on the water's surface, ephemeral and almost invisible, hosted their own chemistries. Organic molecules, less soluble than water, collected at this thin interface where air met sea. There, under the faint caress of sunlight, molecules aligned differently than they did in bulk solution. Surfaces organized, oriented, and sometimes folded. Certain reactions proceeded more readily at the air-water boundary than in deeper columns. These films, so delicate they might vanish with a gust, nevertheless increased the ocean's repertoire of experiments. In their ephemeral existence, they held a paradox. Transience and opportunity entwined, giving fragile things a chance to form and, sometimes, a chance to endure. Over seasons measured not by calendars but by geological pulses, isotopic ratios drifted in minute ways. Lighter isotopes tended to remain in vapor or shallow water, while heavier kinds sank into sediment or were sequestered in minerals. These subtle separations recorded the ocean's behavior in a language of mass, embedding in mineral matrices the signature of processes that had unfolded over eons. The record was quiet but precise. It told of temperatures, of evaporation rates, of the balance between volcanic outgassing and atmospheric absorption. The sea kept these numeric memories with the same fidelity it kept organic fragments, each buried signature, a careful note in a ledger that only stone could one day read. And yet, despite all this cataloguing of salts and sediments, of precipitates and films, the ocean remained indifferent. It remembered without intent. The archive grew because chemistry followed laws that favoured certain paths in the presence of specific constraints. The planet provided constraints in abundance and repetition. Over endless cycles of mixing, settling, heating, and cooling, accident conspired with law to build a repertoire complex enough that novelty could, occasionally, arise and linger. In a quiet margin, where a current slowed and mineral concentration rose, a length of polymer folded into a stable conformation that catalyzed the joining of two smaller pieces. It did so clumsily, imprecisely, with errors and regressions and many false starts, but it did so repeatedly. Each modest success nudged the local chemistry towards stability. The ocean carried that stability outward and inward, dispersing prototypes into other niches where their function might be tested anew. It was not a march, but a scattershot of attempts, any of which could, by a long chain of contingencies, become the ancestor of something bearing memory more explicitly. The oceans did not speak of beginnings. They accumulated traces instead, a patient accumulation that would one day provide the scaffolding for continuity. For now, they were water and salt and deep, slow chemistry, a blue archive that held the memory of stars, stone, and storms, waiting until repetition and circumstance conspired to translate those memories into persistent forms. Before the crust thickened into something the world could walk upon, before oceans cooled into their blue patience, fire shaped the planet from within. It moved beneath stone like a buried intention, slow but restless, gathering pressure where the mantle heaved, and loosening where minerals softened in its glow. This was not the fire of destruction, not the violent outburst that would define later eras, but a quieter persistence, the kind of fire that waits, that listens, that remembers. And what it remembered most intimately were the stars. Deep inside the Earth, heat lingered from two distant origins. The compression of the planet's formation, when dust surrendered to gravity's tightening grip, and the decay of isotopes born in the final breaths of ancient suns. Uranium, thorium, potassium, each carried a memory of stellar endings, of collapsing cores and neutron-whipped furnaces. As these elements decayed, they released their inheritance into the mantle, gentle, continuous warmth that suffused the stone around them. Their quiet radiance shaped the planet from the inside out. guiding the slow movements of plates that did not yet know they would one day drift apart, collide, and reshape oceans. This heat flowed upward in patient tides, buoying molten rock toward the underside of the forming crust. Wherever the crust grew thin, the mantle breathed through it, not in eruptions not yet, but in whispered exhalations of gas and vapor. Carbon dioxide seeped upward, carrying with it the memory of stars that had fused carbon from hydrogen's fragile beginnings. Sulfur drifted in subtle plumes, a faint reminder of cosmic forges where atoms traded electrons under the pressure of collapsing light. Even the metal-rich vapors, iron, nickel, magnesium, carried within them the signatures of supernovae, their isotopes shaped in the violence that had ended ages long before Earth began. The crust responded to this breath with tremors. Fractures opened along still soft ridges, and magma pooled beneath them like thoughts gathering in the hollow between breaths. The surface did not yet crack open in fury. Instead, it softened in places, bulging gently as the molten interior pressed against it. In these bulges, minerals melted and re-solidified in cycles guided only by heat and pressure. Each cycle rearranged the crust's structure, creating pockets of different compositions, silica-rich domes, iron-heavy layers, basalt stretched into thin, brittle plains. These early landscapes were sculpted not by wind or water, but by temperature itself, the unseen hand that carved patterns into stone. The mantle, though molten, was not chaotic. Its flow resembled the slow turn of a dream, drifting in currents shaped by density and heat. These currents churned continents that did not yet have names, lifting some regions upward and pulling others downward. This was the planet's first act of architecture, an interior sculpting that would one day give rise to mountains, valleys, and ocean basins. But for now, these formations remained hidden beneath steam and darkened skies, their shapes whispered into existence by the fire beneath. Sometimes, in places where pressure gathered and the crust hesitated, small eruptions did occur. They were brief and unceremonious bursts of molten rock that spilled onto the surface before cooling into new blankets of basalt. These eruptions did not roar, they sighed. They did not tower into the sky, they seeped. Each deposited layer added thickness to the crust, sealing the world's interior heat just slightly more, forcing the mantle to find new paths upward. In this way, volcanoes were not merely vents but editors, each eruption rewriting the surface, layering fresh material over old, compressing the book of Earth's becoming. Within the mantle itself, crystals formed even in molten depths. Olivine, pyroxene, feldspar, these minerals grew in patterns dictated by cooling rates and pressure, forming lattices that remembered their environments with astonishing fidelity. Every crystal was a journal. Every grain held the exact conditions of its birth: temperature, pressure, chemical neighbors. These minerals traveled slowly upward over millennia, some reaching the crust and cooling further, others being dragged downward again into hotter realms where they dissolved back into the mantle's glow. The planet recycled its memory continuously, erasing and rewriting, folding time into stone. Seismic murmurs traveled across the planet as it cooled. They moved like messages whispered through a sleeping body, faint, rhythmic, carrying no urgency but bearing meaning nonetheless. These waves traveled faster through dense regions, slower through molten pockets, mapping the interior long before any mind would learn to read such patterns. The Earth was not yet aware of these murmurs, but they shaped it, nudging materials into new alignments, redistributing minerals in patterns that would one day define continents. For millions of years, the fire beneath the crust continued this slow work. It did not aim toward life. It did not anticipate oceans or atmospheres or forests. It only followed the rules of heat, of pressure, of descent and uplift. In doing so, it created a dynamic world from the ashes of ancient stars, a world whose surface would eventually host chemistry complex enough to awaken memory more explicit than stones. And through all this, the fire waited. It waited beneath stones' slow thickening, beneath oceans' gathering weight. It waited not for revelation, but because waiting was its nature, the steady persistence of energy seeking equilibrium in a world still learning how to cool. Above it, the crust thickened. Below it, the mantle shifted, and within it, the oldest starlight smouldered on. Beneath the quiet crust, the mantle turned in slow, deliberate spirals, shaping the world with motions so patient they seemed indistinguishable from stillness. Yet nothing within that depth was truly still. Heat drifted upward in waves, reshaping minerals as it passed. Atoms shifted places, lattices stretched and folded, crystals dissolved into liquid only to reform when the temperature dipped a fraction. These transformations happened continuously, without pause or proclamation. They were the planet's earliest form of breathing, an inward respiration of stone, warmed by radioactive decay and the fading inheritance of creation's first fires. The crust above behaved like a thin shell floating on this tide of molten motion. It thickened unevenly, forming higher regions where cooling had progressed more deeply, and thinning in places where mantle heat pulsed upward more insistently. The crust rose and fell like a slow tide, flexing under the shifting weight of internal currents. These movements shaped not only the surface, but the chemistry of the oceans forming above it. Wherever the crust sagged, basins deepened. Wherever it rose, land began to appear bare, dark rock barely cooled from its molten past. The planet was learning its earliest contours, not through erosion or the touch of wind, but through the soft persistence of interior fire. In the deeper mantle, convection cells formed vast loops of rising and sinking material driven by heat, escaping the planet's core. These loops guided the drift of protocontinental fragments, pushing them apart or drawing them together long before any true landmass found its equilibrium. Each fragment of crust carried with it minerals shaped by fire's quiet patience. Olivine that remembered high pressure, feldspar that remembered rapid cooling, pyroxenes that had formed in the thin boundary between liquid and solid. These minerals were not stories of life, but stories of temperature and time, of the planet rearranging itself grain by grain. Occasionally, mantle plumes rose with more force, lifting domes in the crust above them. These domes fractured as they stretched, cracking open like cooled bread under unseen pressures. Magma seeped from these cracks, not violently, but steadily, adding layers of basalt that thickened the crust. With each new layer, the world gained another page in its buried chronicle pages written in textures rather than words, in crystal orientations rather than ink. Over time, these layers would shift, fold, and vanish beneath newer ones. Yet nothing written in the language of stone was ever truly lost. It was merely buried, waiting for some future uplift to reveal it again. The core, deep and hidden, played its role quietly. It radiated heat outward, warming the mantle and sustaining the motions that shaped the crust. Composed largely of iron and nickel, the core carried within its atoms the memory of stellar lifetimes. These metals had once existed in the hearts of stars, forged in pressures far beyond anything Earth could replicate. Their descent to the planet's center during differentiation had been swift, driven by gravity's uncompromising pull. Now they existed in a dense sphere that rotated beneath the mantle's glow, its slow churn contributing to magnetic fields that would one day shield life. But at this stage, the magnetic field was young and unsteady, flickering like a pulse, still learning its rhythm. Above the core and mantle, gases released through volcanic vents shaped the early atmosphere. Carbon dioxide, water vapor, sulfur dioxide, and methane drifted upward in long, curling plumes. Some dissolved into the oceans, forming at the surface. Some lingered in the air, thickening the sky with hazy layers. These gases did not know they were preparing a world. They followed only the laws of pressure and heat, expanding from the crust's cracks like forgotten breaths rising from stone. Yet their influence was profound. They helped regulate the cooling of the planet, trapping heat close enough to maintain the mantle's mobility, ensuring the crust continued to fracture and heal in cycles that would one day create continents. Deep within the mantle, crystals grew along the edges of molten chambers. Their geometries captured the precise conditions of their birth angles, determined by temperature, clarity determined by impurities. In these crystals, isotopes decayed slowly, each decay event releasing a burst of energy that reshaped the surrounding matrix. Over geological time, these bursts influenced how minerals flowed, how they melted, how they reacted with rising plumes. The universe's ancient fire continued its patient influence, guiding Earth's interior architecture through energies too subtle to notice in any single moment. In the stillness of this subterranean world, pressure sculpted minerals into new forms that could not exist at the surface. Graphite deepened into diamond. Olivine transformed into wadsleyite and ringwoodite under crushing depths, each mineral holding more water within its structure than the oceans above could imagine. These transformations meant the mantle carried vast reserves of hidden water trapped in crystal lattices, waiting for the tectonic churn of the planet to release it. Fire and water had already entwined in the world's beginning, each shaping the other from within. Above all these processes, the crust cooled further, becoming more rigid in some places and more brittle in others. When pressure from below built too slowly to erupt, the crust merely bent. When it built too quickly, eruptions broke through, spilling molten rock in slow, glowing sheets. These flows radiated heat into the air, into the forming oceans, into the fractures beneath them. Every eruption added new material to the surface, thickening the crust while thinning the mantle's heat. The balance between interior fire and cooling stone determined the pace of everything that followed, and through it all, the fire waited. It did not demand release. It did not hurry toward the surface. It simply persisted, patient, constant, reshaping the world from beneath the unseen layers of stone. The planet turned, the mantle breathed, and the quiet architecture of continents began to take its earliest, uncertain form. In the depths where sunlight never touched and oceans gave way to the heavy certainty of stone, the planet's interior glowed with a warmth that refused to fade. This glow was not a flame in the ordinary sense. It did not flicker or roar. It drifted like a vast ember, its heat spreading outward through minerals that strained under its influence. The mantle's slow churn continued, carrying atoms that had once belonged to distant stars into new shapes and new places. Every movement, no matter how slight, contributed to the Earth's unfolding architecture, a world sculpted from beneath, long before winds carved valleys or rivers traced their wandering lines. Along the mantle's rising plumes, molten rock ascended with the measured pace of something that had never known haste. When it neared the base of the crust, it slowed further, spreading horizontally beneath the rigid shell. This lateral drift exerted pressure in ways subtle yet persistent, bending the crust upward in some regions while stretching it thin in others. The crust, unsure of its strength, responded with fissures. These fissures were not violent scars but soft openings through which gases seeped and minerals oozed. They were the planet's early vocabulary of change, small exhalations of fire, small rearrangements of stone. Each fissure carried whispers of the world's interior. Carbon dioxide rose through them in faint plumes, dissolving into atmospheric water vapor before falling back to the surface as carbonic rain. These rains softened rock, contributing to the first cycles of erosion. Sulfur compounds drifted upward as well, infusing the air with a faint, metallic scent invisible to the senses a future world would one day have. Even noble gases escaped argon, neon, helium elements that held memories of the universe's earliest moments. Their release did not change the surface dramatically, but their presence in the atmosphere became another quiet signature of the fire below. This fire shaped minerals in the crust with unusual precision. As temperatures shifted, crystals melted on one side of a fracture and recrystallized on the other. Over time, these cycles created bands of stone with distinct textures, each layer recording the temperature at which it formed. These bands became the earliest pages of the planet's geological chronicle. Yet much of this writing would remain hidden for billions of years, buried beneath later upheavals, unread until continents drifted and mountains rose. Still, the record grew, page by page, with the slow confidence of something that expected to be found eventually. Further below, the mantle continued its transformations. Minerals exposed to extreme pressure altered themselves into new forms, denser, more compact, able to withstand the crushing weight above. These transformations occurred without rupture. They resembled slow awakenings, minerals shifting into arrangements they had always been capable of but had never needed before. Some of these high-pressure minerals could trap water in their lattice structures, storing it deep within the earth. This hidden water, though not liquid, played a quiet role in the planet's behavior. It softened rocks enough to allow subduction, enabling oceans to sink into the mantle and return later through volcanic activity. Thus, cycles of water and fire intertwined long before life existed to remark upon their balance. Occasionally, a particularly strong plume of rising magma pushed against the crust with enough force to create volcanic islands. These islands emerged from the ocean like slow thoughts surfacing through layers of memory. They were barren at first, composed of dark basalt that cooled quickly and fractured easily. Rain fell on these new rocks, dissolving minerals that washed back into the sea. These minerals enriched the oceans, altering their chemistry in subtle but meaningful ways. The islands themselves were temporary waves eroded them, and fresh eruptions replaced them, but their contributions to the planet's systems were lasting. They offered new surfaces for reactions, new materials for the ocean to examine, new fragments for future sediments. As the crust continued to thicken, subduction zones developed. In these regions, one section of crust slid beneath another, returning surface materials to the mantle's soft glow. Stone that had once cooled in the presence of sky and ocean now dissolved back into molten depths, merging with material that had not seen the surface for millions of years. This return was not a destruction but a continuation, a reminder that nothing in the planet's early life was permanent. Everything was part of a cycle, from molten rock to solid stone to molten rock again. These cycles enriched the mantle with new elements, adding diversity to the material rising through plumes. Through this ongoing dialogue between surface and interior, the planet refined itself. The core, still cooling but immensely hot, contributed to this slow choreography. Convection within the outer core helped sustain the planet's nascent magnetic field, a shield not yet stable, but one that flickered with promise. Lines of magnetic force extended outward, interacting with charged particles in the upper atmosphere. These interactions guided atmospheric flows, influencing how gases moved across the planet. Though the magnetic field was faint, it contributed to the planet's identity in ways that would matter deeply in ages to come. Above all of this, the crust's surface began to settle. Though volcanic activity remained frequent, long stretches of relative calm allowed regions of crust to harden. These regions would become the seeds of continents, small protocontinental plates, buoyed by their slightly lower density compared to surrounding oceanic crust, resisted subduction and accumulated material over time. They drifted slowly across the mantle, guided by currents beneath them. Their movements were the first hints of a world that would one day rearrange itself repeatedly, its face never fixed. Through all these transformations, fire remained the quiet architect. It did not announce its intentions. It did not reveal its blueprints. It simply persisted, transferring energy, reshaping materials, allowing complexity to rise from the interplay of temperature, pressure, and time. The fire beneath stone was not a destroyer but a patient sculptor, carving the structure of the world long before life placed its first footprint upon it. And still, it waited for oceans to deepen, waited for continents to find their paths, waited for the chemistry above to gather enough memory to reshape itself. The planet spun in darkness, its interior glowing like the echo of a star that had never stopped burning. Deep within the mantle, the world's quiet furnace continued its ceaseless meditation. Heat rose through the stone not as a surge, but as a slow unfurling and ancient warmth inherited from the collapsing cores of stars and from the planet's own turbulent birth. This heat pressed upward in soft pulses, meeting the underside of the crust like a memory searching for a place to surface. And each time it met resistance, the crust responded with subtle shifts, bending here, cracking there, forming deep scars that would one day become mountain ranges, ocean floors, and the drifting fragments of continents. The crust itself, though solid in comparison to the glowing depths below, carried its own kind of softness. It thickened unevenly, forming rigid plates interspersed with fragile seams where the mantle's breath could seep through. These seams were the planet's earliest conversation points, openings through which fire and stone exchanged their slow messages. Gases escaped from these fractures, carrying with them the chemical signatures of ancient stars, carbon that once fueled the fires of red giants, sulfur-shaped in the last instants of stellar collapse, noble gases that had drifted through the galaxy long before Earth existed. As these gases entered the early atmosphere, they altered the sky's composition gently, setting the stage for oceans that were still gathering their strength. In some regions, the crust thinned more than in others. Here, the mantle rose nearer to the surface, creating zones of heightened warmth that softened rock until it behaved more like clay than stone. Over millions of years, these regions expanded and contracted. Lava seeped upward in slow ribbons, cooling into layers of basalt that built upon one another like pages stacked in silence. Each new layer captured the temperature of its birth, the orientation of the magnetic field at the time it cooled, and the chemical mixture of the mantle plume that fed it. These details were not appreciated by the world above, but the stone held them faithfully, storing them until some distant epoch when time might reveal them again. Volcanoes emerged where pressure exceeded restraint. But even these early volcanoes lacked the ferocity seen in later ages. Their eruptions were muted, their plumes low and heavy with minerals. Lava spread in thick sheets that hardened into black expanses, their surfaces fractured by rapid cooling. Rain fell upon these new lands, drawing minerals from the rock and carrying them to the oceans. In this exchange, fire and water shaped each other. The sea gained salts and metals, while the crust lost fragments of its composition, allowing erosion to sculpt features that seemed accidental yet persistent. Within the mantle, minerals continued to undergo transformations under crushing pressures. Some structures collapsed and reformed into denser arrangements, releasing subtle pulses of energy as they shifted. Others trapped water within their lattices, holding it until tectonic movement forced them upward where heat would release it again. This hidden cycling of water through the mantle enriched volcanic eruptions with steam and gases, thickening the atmosphere and feeding the planet's cooling rhythm. In these exchanges, fire acted not as an adversary to water, but as its partner, each shaping the other in ways that would eventually make life possible. Subduction zones deepened as the crust cooled further. Heavy slabs of oceanic plates slid beneath lighter protocontinents, descending into the mantle where they heated, melted, and rejoined the churning interior. This descent carried not only rock but memory sediments from shallow seas, minerals altered by early ocean chemistry, even tiny traces of organic fragments that had begun to form in the water above. Though these fragments did not survive the journey intact, the chemical richness they brought with them subtly altered the mantle's composition. The fire that waited beneath stone began absorbing the earliest whispers of the ocean's experiments. Plumes rising from these altered regions carried new chemistries toward the underside of the crust. Some plumes created volcanic arcs, others spread beneath the crust like unseen rivers of heat. Wherever these plumes accumulated, the crust bowed upward, forming the seeds of future mountain ranges. These mountains, though bare and black at first, introduced elevation into the planet's geography, a beginning hint of landscapes that would one day host forests, rivers, and fields of ice. The core, still molten and restless, played its role with silent consistency. Its spinning iron released magnetic patterns that flickered unpredictably, reversing direction, strengthening, weakening. These early magnetic fields offered only faint protection, but they guided charged particles in the atmosphere, influencing the distribution of gases and shaping the sky's evolving chemistry. Fire, even here, extended its influence outward from the depths, reaching into regions of air that did not yet know how to hold light. Occasional mantle plumes reached the surface, with enough force to create vast volcanic provinces, regions where lava flowed across hundreds of kilometers in slow, glowing waves. These flows were unbroken, steady, covering older surfaces and resetting the planet's geological canvas. The thickness of these basalt sheets insulated the mantle further, altering the patterns of heat escape. The interior adjusted, shifting convection cells, redirecting plumes, rebalancing the great engines that powered the planet from within. Through all these transformations, fire remained restrained. It did not consume the world. It shaped it. It introduced variety into the crust, enriched the oceans with minerals, sculpted the sky with gases, and rearranged continents before continents even knew they were such. This was a fire that understood patience not consciously, but intrinsically. It persisted because the universe had taught it persistence in the hearts of stars, where lifetimes are measured not in moments but in eras. The mantle glowed, the crust thickened, and in the spaces between molten and solid, between heat and stone, the planet continued rearranging itself into a world capable of holding futures. The fire beneath waited still, its story far from finished. There were places on the young Earth where nothing seemed promised, where the world exhaled quietly into itself, leaving behind pockets of stillness untouched by storm or tide. These places, warm shallows, shaded pools, lightless cracks in volcanic stone, did not announce their importance. They simply existed, small refuges where heat and mineral, water and element gathered without purpose. And yet, within these unremarkable hollows, chemistry began its first hesitant dance. The planet, though still voiceless, had begun to hum. In the shallows near new coastlines, sunlight warmed thin layers of water that pressed gently against stone. These warm films created environments where molecules drifted closer together, not because they sought one another, but because water's embrace narrowed their wandering paths. Carbon compounds, some formed in the atmosphere, others delivered by meteors, drifted into these shallows. There, they found minerals dissolving from the rocks, salts, metals, silicates, and the presence of these minerals shifted their behavior. Some molecules loosened bonds and recombined, others clung to surfaces, forming faint films that thickened each time the water evaporated beneath soft sunlight. Evaporation, though slow, was a sculptor. As the water thinned, concentrations grew. Molecules that would not have met in the open sea found themselves pressed into accidental proximity. Chains formed, wavered, and fell apart. Rings assembled only to unravel into simpler fragments. But each cycle, evaporation, concentration, dilution with returning waves, became a gentle rehearsal for the planet's first experiments in persistence. The chemistry remained fragile, but it lingered just long enough to imprint patterns into the environment, creating echoes that repeated with every cycle of sun and water. In deeper cracks where sunlight could not reach, warmth came from below. The mantle's ancient heat seeped through the crust, warming water trapped between fractures. These lightless spaces were quiet in a different way. Without the variability of surface conditions, reactions proceeded steadily, shaped by gradients of heat rather than cycles of light. Minerals lining the cracks offered surfaces with charge patterns that guided molecules into arrangements they might not have discovered alone. Iron-sulfur clusters formed, dissolving and reforming as water pulsed through the tiny caverns. These clusters behaved like early catalysts, not alive, but capable of nudging reactions forward. Hydrothermal vents along the ocean floor breathed out plumes of mineral-rich water. Their warmth created pockets of gradient, where hot and cold met in delicate balance. In these gradients, molecules encountered rapid changes in environment cooling, heating, mixing conditions that encouraged complexity. Simple organic compounds could form in the vent fluid, only to drift outward into cooler waters, where they assembled into chains or folded into shapes that delayed their dissolution. These chains were short-lived but instructive. Their impermanence was part of a slow, expanding vocabulary. Clay minerals, abundant in shallows and along volcanic slopes, provided sheets and surfaces on which molecules could align. Their layered structures held organic fragments between thin planes, shielding them from dilution. When water flowed over these layers, the fragments shifted, reorganized, and bound to one another in new ways. Clay acted as a quiet archivist, storing molecular arrangements that might otherwise vanish. As the environment changed, warming, cooling, drying, the clay released its fragments, offering them back to the water in altered configurations. Each release was a new beginning, a chance for molecules to explore different arrangements. In certain protected pools, carbon compounds began forming longer structures. These chains were unstable, prone to breaking if waves grew too strong, or if temperatures fluctuated sharply. Yet some held together for several cycles of evaporation and replenishment. Their persistence, however brief, allowed them to encounter other molecules and form more elaborate assemblies. Hydrogen, the oldest element in the universe, threaded itself through these evolving structures, its simple bonds anchoring complex formations that memory would one day call organic. Oxygen, reactive and eager, inserted itself where it could, reshaping the chemistry into something more varied. The world was still silent, but silence was no longer emptiness. The chemistry of quiet places carried a subtle pulse, a rhythm shaped by the planet's breath, tides, winds, geothermal murmurs. Molecules responded to this rhythm, dancing through their ephemeral choreography. They flowed into cracks, seeped into mineral pores, gathered in pools that existed for only brief epochs before shifting landscapes erased them. Each location contributed something different: warmth, concentration, catalytic surfaces, gradients. Nothing alive guided these processes, yet the environment was rich with possibilities, waiting for enough repetition to turn accident into stability. In darkness, reactions occurred that light would have disturbed. Aspiring structures formed not by energy from the sun, but by the gentle encouragement of heat rising from the interior. Ammonia, created in the early atmosphere and dissolved into oceans, drifted into these warm pockets. Combined with carbon dioxide and other organics, it participated in reactions that produced molecules capable of storing small amounts of energy. These molecules, though unstable, represented something new, the faintest suggestion of chemistry that could fuel itself. Meanwhile, water ancient hydrogen paired with stellar-forged oxygen continued its quiet sculpting. It dissolved minerals and created gradients. It carried molecules from one reaction site to another. It cushioned fragile structures, allowing experiments to proceed without immediate dissolution. Water, with its polarity and persistence, became the first caretaker of complexity. It did not direct the chemistry. It only created the conditions in which persistence could find a foothold. Occasionally, a chain of molecules would form that folded in a way that protected part of itself. This fold allowed the structure to last longer than others. When it finally unfolded or broke apart, fragments drifted into neighboring reactions, nudging them towards similar configurations. The environment itself, stone, water, heat, amplified these repetitions. Through cycles innumerable, these fragile continuities began to resemble something like memory, and thus, in the quiet places of the world, shallow, warm, and hidden, deep, dark, and patient chemistry crossed the trembling boundary between possibility and pattern. It was not life, not yet, but it was the beginning of something that could one day learn to remember. In the warm, protected shallows, the planet rehearsed chemistry with the same patience it used to cool stone and gather oceans. Each tide left behind thin films of organic matter that adhered to mineral surfaces only to be washed away when the water returned. These films were fleeting, erased and rewritten by the rhythm of waves. Yet even in their impermanence, they carried a quiet momentum. With every cycle, the concentration of molecules shifted slightly. Some structures survived longer than others. Some formed more readily. Patterns began to emerge, not because they were favored intentionally, but because the environment offered them just enough time to gather themselves before dissolving again into the vastness of the sea. In these shallows, heat from the sun played a subtle, guiding role. As water warmed, molecules moved with more freedom, forming and breaking bonds at a pace that allowed complexity to find footholds. When night cooled the pools, reactions slowed, preserving certain arrangements until dawn returned to loosen them once more. This alternation, warmth and coolness, movement and stillness, was the earliest rhythm the world offered, a primitive cycle that shaped chemical possibility, molecules that could endure both conditions, or that could reform easily after disruption, appeared more often. Fragility remained the rule, but persistence began to whisper at the edges of chance. In deeper, lightless cracks, a different rhythm unfolded. Here, heat flowed not from the sky but from the mantle itself, rising through narrow spaces in stone. Water seeped into these cracks, carrying dissolved minerals from the surrounding rock. In these tight corridors, reactions were guided by geometry. Surfaces curved and angled in ways that encouraged molecules to align, fold, or bind. Iron-sulfur compounds, abundant near volcanic activity, arranged themselves into clusters capable of transferring electrons, tiny sparks of energy that nudged nearby reactions forward. These clusters were the planet's first catalysts, enabling transformations that water and heat alone could not sustain. The darkness of these cracks sheltered reaction cycles from ultraviolet light, which would have broken fragile molecules apart. Here, in the absence of light, Molecular structures experimented with stability. Chains formed and collapsed. Rings assembled, dissolved, and reassembled with slight variations. The environment acted as both container and guide, offering a continuity that the surface waters could not. If the shallows were the world's teacher of rhythm, these cracks were its instructor of patience. Reactions here did not rush. They unfolded slowly, exploring variations without interruption. On the ocean floor, hydrothermal vents released streams of mineral-rich water into the surrounding cold. These vents created miniature worlds defined by gradients, zones where hot met cold, acidic met alkaline, rich met barren. The boundaries between these zones became fertile grounds for chemical transitions. Molecules drifting from one side of a gradient to another experienced sudden shifts in stability, folding or unfolding in response. Some arrangements held only briefly, while others persisted long enough to meet additional molecules and form larger assemblies. These interactions were neither random nor directed. They were guided by physics, by the quiet insistence of energy-seeking pathways to dissipate. Within the porous walls of vent chimneys, tiny compartments formed chambers only micrometers wide, yet numerous enough to host entire landscapes of reaction. These compartments trapped molecules, reducing dilution and increasing the chances that complex structures would form. Each pore offered slightly different conditions, some warmer, some cooler, some richer in metals, some more acidic. The diversity of these microenvironments allowed countless experiments to unfold at once. Most failed immediately. A few persisted across cycles. One or two found new forms of stability, offering templates that might be echoed in other pores nearby. Meanwhile, clay minerals continued their quiet work in shallower regions. Their layered structures absorbed organic fragments, aligning them into patterns that free-floating molecules did not adopt on their own. When the clay dried, these fragments became temporarily locked into place. When water returned, the structures were released in altered forms, some more stable, some less. This constant reworking created a primitive form of selection, not driven by purpose, but by the physics of surfaces and the repetition of cycles. Clay became a silent editor, preserving what could endure and discarding what could not. Hydrogen, ever abundant and ancient, drifted through these processes like a patient companion. Its bonds formed easily and broke easily, offering flexibility that more complex elements could not. Carbon, with its unique ability to form intricate chains, served as the backbone for emerging complexity. Oxygen joined where it could, introducing reactivity that altered the chemistry's pace. Nitrogen participated in reactions that produced molecules capable of storing small amounts of energy, rudimentary energy currencies that hinted at later biological processes. None of these elements knew purpose. They merely followed their tendencies, aligning with physics and chance in patterns that grew more intricate with each cycle. Occasionally, external events stirred these quiet places. A meteor impact far away sent shockwaves through the crust, altering the temperature of cracks and vent fields. Volcanic eruptions on the seafloor released new minerals into circulation. Storms on the surface churned sediments, introducing fresh clay and metal ions into shallow pools. Each disturbance altered the chemistry slightly, providing new opportunities for complexity to arise. Some fragile structures were destroyed. Others found conditions that suited them better than before. The environment was never static. It was a shifting mosaic of possibilities. Despite these changes, the world remained silent. There were no cells, no membranes that held their contents with purpose, no replication that carried information forward with fidelity. But there were patterns that emerged, dissolved, and returned with increasing clarity. Chains that formed more readily. Structures that folded more consistently. Interactions that repeated often enough to resemble the earliest gestures of inheritance. The chemistry of quiet places did not rush toward life. It drifted toward it, carried by cycles and gradients, by surfaces and heat, by the patient sculpting of water. These places remained humble pools, cracks, compartments, but within them, the first hints of possibility gathered like mist preparing to condense. And in this gathering, the world grew less empty, still silent, but no longer silent alone. In the sheltered corners of the planet, where waters pooled in dim recesses and minerals shaped the flow of time, Chemistry began stitching together moments that would otherwise have been lost. Each reaction was small, a fleeting bond, a temporary fold, a brief exchange of electrons, but repetition turned these small gestures into something that felt almost deliberate. The world had not yet awakened, but it was no longer dreaming alone. Its quiet places were becoming meeting grounds where the universe experimented with continuity. Warm shallows near volcanic shores continued to host fragile chains of carbon-based molecules. When sunlight touched the surface, it warmed the water just enough to alter the movement of ions and fragments drifting within. Molecules shifted, some gaining energy, others losing it, creating a gradient of activity that varied from one wave to the next. As water evaporated throughout the day, the concentrated solution thickened into a viscous layer where reactions accelerated. When night returned, cooling the film, the thickened solution contracted, and molecules nestled closer together, like pages of a book pressed tight. This compression was not enough to preserve structures for long, but it prolonged their interactions, allowing newly formed sequences to linger in the slow hush of evening. The chemistry in these shallows was chaotic, but not random. Minerals in the rocks, iron, calcium, magnesium, leached into the water and acted as subtle guides, directing certain bonds to form more readily than others. Some surfaces encouraged linear chains to attach temporarily, aligning them into shapes more stable than they would have achieved alone. Other surfaces coaxed rings to close, creating cyclic structures that resisted immediate dissolution. Over countless cycles, these mineral-guided interactions favored certain forms, granting a quiet advantage to the molecules that could maintain themselves even briefly. In the dark interiors of the Earth's crust, far from wind and sunlight, chemistry unfolded with greater steadiness. Water filtered downward through cracks and fissures, heated by the mantle below. Here, heat did not fluctuate. It persisted, creating a world where reactions progressed without interruption. Iron-sulfur minerals crystallizing along the walls of these fractures provided both scaffolding and catalysts. Their jagged surfaces collected organic fragments, holding them in place long enough for reactions to proceed with greater efficiency. These fragments stacked, folded, and occasionally formed small networks capable of sharing electrons, a primitive exchange that hinted subtly at energy transfer. Within these fractures, variations in pressure contributed to unusual chemical behaviors. Some minerals released trapped gases when heated, adding carbon dioxide and hydrogen into the mixture. These gases dissolved differently depending on depth and temperature, creating pockets rich in reactants that drifted slowly along the fracture walls. When a pocket of gas met a cluster of reactive molecules, new combinations formed, some unstable, others briefly enduring. In this dim, patient realm, the chemistry began to develop a rhythm, not imposed from outside, but arising from the architecture of stone itself. Hydrothermal vents at the ocean floor deepened this complexity. Their warm, mineral-heavy plumes billowed into cold, oxygen-poor waters, creating sharp gradients that invited molecules to behave differently depending on position. In zones just outside the vent's mouth, where heat faded gradually into the surrounding sea, molecules folded into shapes that were impossible in colder water. Some structures accumulated on the surfaces of vent chimneys, forming thin films that clung to mineral walls. Others drifted away, caught in rising currents, carried into layers where their structure shifted again. These shifts were not random. They were reactions to changes in temperature, pH, and metal availability. The ocean, in its quiet way, was training the chemistry to adapt. The pores of vent chimneys created a labyrinth of shelters. Each pore differed slightly. Some were narrow, others wide. Some acidic, others alkaline. Some warm, others cool. Within these countless microhabitats, chemistry diversified. Molecules that might fail in one pore found stability in another. Structures that dissolved in open water persisted longer in confinement. The vent system acted like a vast experimenter, hosting parallel trials across thousands of tiny chambers. Most combinations vanished without leaving a trace, but a few endured long enough to serve as foundations for more complex reactions. As molecules traveled between environments, shallow pools, deep cracks, hydrothermal plumes, they encountered new partners and new conditions. A chain formed in a warm pool might drift into the ocean, where colder temperatures forced it to fold differently. A ring structure born in darkness might ride a current into a lighted shallows, where ultraviolet energy would break it apart, scattering its fragments into the chemistry of the next tide. These transitions blurred borders between environments, blending the lessons of each region into a shared chemical vocabulary. Water remained the quiet conductor of this emerging complexity. Its polarity aligned molecules in certain orientations. Its movement transported fragments across thresholds where reactions changed direction. Its ability to dissolve and release minerals shaped the availability of catalysts. It softened the harsher impulses of heat and pressure, cushioning reactions that might otherwise have collapsed. Through its patient sculpting, water carried the world's earliest chemistry from disarray toward coherence. At times, reactions appeared to approach something like self-assembly. Molecules formed compartments, hollow structures bounded by lipid-like films that enclosed solutions within their fragile walls. These compartments were temporary, dissolving at slight disturbances, yet their presence introduced a new concept into the world, inside and outside. When compartments formed, reactions occurred within them that differed from those in the surrounding water. Concentrations rose, structures met more frequently, stability lasted longer. Each compartment was a momentary sanctuary, a quiet place within a quiet place. Though none of these systems could replicate themselves yet, echoes of replication emerged. A chain that could align with another chain, guiding its assembly, appeared more often. A structure that folded predictably at certain temperatures tended to reform after breaking. These were not life. They were not even precursors in a direct sense. They were tendencies, habits of chemistry that favored persistence, gathering weight as cycles continued. In the hidden recesses of the world, nothing spoke. Yet in the silence, chemistry began leaning toward continuity, toward the possibility of a future where memory could extend beyond molecules. The world remained quiet, but its quiet places were beginning to think in patterns. In the world's most hidden corners, chemistry continued its soft rehearsal, layering one fragile experiment atop another until the quiet places swelled with possibility. There were no cells, no membranes with purpose, no breath to stir the water, only the trembling edge of emergence, where matter behaved just differently enough to hint at futures it could not yet imagine. These moments did not occur in grand environments, but in the smallest spaces. A sheltered tide pool warmed by morning light, a grainy fissure deep within volcanic stone, a porous chimney on the ocean floor, where hot and cold waters braided into gradients of change. In these quiet places, carbon remained the central storyteller. Its bonds formed with ease, broke with reluctance, and reformed in patterns that widened the landscape of chemical possibility. Chains of carbon, loose and flexible, drifted through warm pools, brushing against mineral surfaces that nudged them into subtle bends. Sometimes these chains curled into spirals, not stable enough to last through the night, but strong enough to cradle additional molecules before unraveling. Rings formed two aromatic circles of carbon that echoed with a faint suggestion of structure. These rings tended to resist dissolution, remaining intact even after waves swept through the shallows. Something in their symmetry gave them a slight advantage, a persistence that carried them from one tide to the next. Water shaped these processes with gentle insistence. It was at once a creator and a destroyer, dissolving molecules even as it brought new reactants into proximity. In pools that dried under sunlight, solutes concentrated until their interactions became unavoidable. A molecule that might once have drifted freely now brushed against others dozens of times in a single afternoon. Concentration birthed complexity, yet when rain returned, dilution erased many of these structures, scattering their fragments back across the basin. This perpetual cycle, drying, thickening, dissolving, was a natural rhythm that carried subtle consequences. Molecules that could survive dilution appeared more often in the next cycle. Complexity that dissolved instantly vanished from the rehearsal. The world, without intention, edited itself. Deep cracks beneath the crust offered a different kind of editing. Here, the water retained heat, maintaining temperatures suitable for sustained reactions. Minerals such as pyrite formed crystalline scaffolds on the fracture walls. These surfaces captured organic fragments and guided their assembly in ways unique to their geometry. Some surfaces favored long, linear chains, Others supported branching structures. The cracks became galleries of molecular architecture, each pattern influenced by the conditions that shaped it. Over time, patterns that formed more easily or that required less energy to maintain accumulated. Chemistry began to exhibit preference, not purpose, but tendency. Hydrothermal vents, breathing heat from the mantle, introduced further variation. Their mineral-rich plumes carried clusters of iron, sulfur, and trace metals into the cold ocean. These clusters acted as catalysts, helping molecules fold or bind in ways that would have been improbable otherwise. The plumes themselves were dynamic. As they rose, they cooled, depositing minerals that formed chimney-like structures with interiors riddled by tiny channels. Within these labyrinths, gradients of temperature and chemistry formed natural incubators of complexity. A molecule drifting into one chamber might encounter conditions vastly different from those in another, prompting new folds or new bonds. These quiet places were not static. They shifted, collapsed, rebuilt. Yet the continuity of vents ensured endless opportunity for experimentation. Occasionally, chains of molecules assembled into shapes that enclosed water within their folds. These protocompartments were not true membranes, but they created a brief distinction between inside and outside. Within the enclosed space, concentrations of molecules rose slightly, allowing reactions to proceed with greater consistency. Some compartments dissolved almost instantly. Others survived long enough to influence reactions around them. In these small, impermanent pockets, chemistry acquired a degree of autonomy, faint, flickering, but meaningful. The world was not alive, but it was learning to hold its chemistry in place. Nitrogen contributed a quiet strength to these processes. When bound into certain sequences, it created sites where molecules could store small packets of energy. These energized structures did not persist long, but their brief presence shifted the reactions around them. Oxygen, present in limited amounts, introduced reactivities that reshaped the direction of molecular growth. Hydrogen, smallest and oldest, threaded through these reactions like a needle-stitching fabric binding, releasing, returning. Together, these elements behaved not randomly, but with a kind of collective choreography shaped by physics and environment. Storms and volcanic activity introduced periodic disruptions. A sudden rainfall diluted a pool that had spent days concentrating its chemistry. A shift in the seafloor altered the flow of vent water, cooling some regions while warming others. Ash fell from eruptions, delivering new minerals that altered local conditions. These disruptions erased many fragile structures, but they also created new starting points. Variation, introduced by the planet's own restlessness, expanded the range of possibilities. Structures that survived these disturbances carried forward their forms into the next cycle, becoming quiet seeds of pattern. With time measured not in days, but in cycles of heat, water, and stone, certain molecular arrangements began to echo themselves. A chain that folded in one environment folded similarly when returned to it. A ring that resisted dissolution did so reliably. A cluster that aligned with a mineral surface found the same stability again. These echoes were primitive forms of inheritance, though nothing yet replicated in any true sense. Still, repetition carved familiarity into the landscape of molecules, granting the planet its first fragile memory. In these quiet places, emergence did not declare itself. It wandered gently across gradients, seeped along mineral surfaces, drifted through tidal rhythms. Complexity gathered not through intention, but through accumulation. The world remained silent, but its silence was textured, now woven with the soft murmur of chemistry refining itself in pools and cracks and vent-lit chambers. And though nothing alive yet stirred, the earth was no longer a passive stone beneath the stars. It was beginning to organize, to cohere, to almost remember. Life did not arrive in a moment. It did not burst forth like lightning across a darkened sky. It gathered grain by grain, bond by bond, in places so quiet that even the planet itself seemed unaware of what was beginning. In the warm pools of ancient shallows, in the hidden pores of vent-formed stone, in the deep cracks where warmth rose from the Earth's interior, chemistry had rehearsed its patterns until some of those patterns began to behave as though they remembered themselves. And from this, memory fragile, trembling, easily lost the earliest creatures emerged. They were not creatures in the sense the world would later understand. They had no eyes to see with, no limbs to move on, no voice to name their existence. They were arrangements of matter, held together by persistence rather than purpose. But they endured, and in enduring, they crossed the first boundary between chemistry and life. In the sheltered places where molecules had practiced folding and unfolding, certain arrangements found ways to preserve their shapes longer than others. These arrangements formed loops, cycles, that repeated themselves, slowly at first, then with growing steadiness. Where once a chain might form and dissolve in the span of a passing wave, now some chains lingered. They grew capable of acting as templates, guiding fragments around them to align in similar patterns. This was not replication, not truly, but it was the world's first attempt at continuity. Patterns that could echo themselves began to accumulate, and with accumulation came the faintest hint of identity. Water cradled these beginnings with its patient touch. In tidal pools, thin films dried under the sun, forcing molecules into proximity until they bonded into fragile scaffolds. When the tide returned, these scaffolds broke apart, sending fragments drifting into new corners of the pool, where they reassembled with slight variations. The environment served as both canvas and sculptor, rewriting these early forms countless times. Among these variations, some structures emerged slightly more resilient, slightly better suited to reform themselves when broken. These subtle advantages allowed them to persist across cycles, becoming quiet seeds of inheritance. In deeper regions near hydrothermal vents, compartments bounded by primitive membranes began to appear more consistently. These boundaries were not fully stable. They formed from lipid-like molecules that assembled spontaneously under certain conditions. Yet once formed, they enclosed pockets of fluid that differed from the surrounding ocean. Within these tiny chambers, molecules could interact in increasing concentration. Reactions occurred in sequences rather than in isolation. Energy gradients across the primitive boundaries nudged certain reactions forward. These enclosed chemistries represented a new frontier, the world's first experiments in autonomy. The earliest creatures, if the term can be used at all, were little more than these enclosed chemistries held together by films and threads. They did not swim, they did not hunt, they did not sense, they simply persisted longer than the structures around them. And persistence, in this dawn of unwritten life, was everything. These first beings carried within them dust from long-dead stars, dissolved minerals from Earth's young crust, and the thermal energy rising from the planet's mantle. Every part of their existence was borrowed, yet the way they combined these ingredients made them something new. They were not merely chemistry anymore, they were continuity. Some of these early forms drifted upward along currents, carried from dark vent regions into warmer waters above. In this transition, many dissolved, unable to withstand the changing temperature and salinity. But some adapted not through intention, but through inherent flexibility in their structure. These survivors learned, in their own passive way, that environments could shift and persistence required adaptation. Others remained near the vents, clinging to their mineral scaffolds, absorbing energy from chemical gradients that pulsed steadily through the porous rock. These deep dwellers experienced stability unlike their surface counterparts, allowing them to refine their internal cycles through countless iterations. Within these early cycles, the first hints of metabolism flickered. Molecules encountered gradients of heat, of charge, of chemical concentration, and began to rearrange themselves in ways that released small bursts of energy. These energies fed back into the system, stabilizing certain reactions. Though crude and unreliable, these internal flows represented the earliest whispers of life's defining characteristic, the ability to maintain order against the natural pull of dissolution. These first creatures did not think or choose. They simply survived because their structures allowed them to resist entropy a moment longer than their neighbors. As these structures persisted across cycles, their components began to specialize. Some molecules became better suited to capturing energy from the environment. Others became better at forming the boundary that held the system together. Still, others served as templates for their own assembly, enabling a primitive form of inheritance. These roles were not assigned. They emerged from the natural tendencies of the molecules involved. Yet together, They created systems more stable than any that had existed before. These systems drifted through the world in silence, carrying the first sustained forms of organization. The planet took no notice of this shift. Oceans continued their slow churn. Volcanoes exhaled. The crust rose and fell in quiet tectonic murmurs. The sky thickened with clouds of vapor and ash. But in shallow pools, in dark crevices, in mineral chambers warmed by the mantle's breath, something unprecedented was happening. Matter was beginning to remember itself not in conscious thought, but in structure. The dust of ancient stars, scattered across space and gathered into a small world of stone and water, had begun to assemble itself into forms that could endure. These first creatures, unwritten, unnamed, unnoticed, were the earliest storytellers. They carried the universe's history in their atoms and Earth's emerging narrative in their fragile continuities. They did not speak, yet every fold, every bond, every cycle was a quiet declaration. Something new is forming. Something that will outlast the chemistry that birthed it. Something that will, in time, shape the world that shaped it. In the faint glow of Earth's earliest dawns, before the sky learned to clear and before continents understood their outlines, these first unwritten creatures lingered in water, as quiet as breath, resting between sentences. They did not move through intention, but through drifting currents. They did not grow through hunger, but through the patient borrowing of energy from minerals, lightless gradients, and the whisper of chemical change. They existed at the threshold where matter began to organize itself with enough stubbornness to endure. Their fragility was profound. A single shift in temperature or salinity could unravel them. Yet despite this fragility, or perhaps because of it, they adapted with a softness that defied the stillness of their world. Some of these earliest beings clung to mineral surfaces. They were held in place not by will, but by charge, the faint electrostatic pull between their fragile boundaries and the stone beneath them. Here, in the stability of attachment, they found a rhythm. Mineral surfaces served as guides, aligning molecules within the boundaries of these early forms. Reactions unfolded in predictable sequences, allowing certain structures to reinforce themselves. These anchored creatures remained sheltered from the turbulence of water above, protected within the silence of stone. Their existence was humble, yet in their stillness they refined the earliest cycles of continuity. Others drifted freely. Swept by currents, they encountered chemical gradients that coaxed them into new shapes. A swell of warmer water might cause a boundary to expand, stretching the fragile enclosure around its internal patterns. A sudden cooling would contract the structure, pressing its contents together as though encouraging interaction. These expansions and contractions were not purposeful, but they allowed new combinations to form. Some combinations collapsed instantly, folding back into simpler arrangements. Others lingered, producing faint internal flows of energy, soft echoes of the metabolism that life would one day wield with force. In the dark regions near hydrothermal vents, creatures adapted to the chemistry of the deep. They absorbed energy not from sunlight, which never reached them, but from chemical gradients exhaled by the Earth's interior. These gradients provided a slow, steady nourishment, allowing reactions within the boundaries of these beings to proceed without interruption. They were sheltered from surface storms, shielded from the churning sea, held gently in the warm darkness where the planet's breath rose through mineral chimneys. Their boundaries thickened slightly over time, not through design, but through repetition. The molecules that formed more stable enclosures appeared more frequently, granting these deep-dwelling creatures a quiet resilience. In shallower waters, where sunlight filtered through vapor-laden skies, something different occurred. Though early sunlight lacked the clarity and force of later ages, it carried enough energy to influence the chemistry of these drifting forms. Some creatures absorbed this light unintentionally. The energy did not nourish them. It destabilized their structures. Boundaries ruptured, chains broke apart, cycles dissolved. But occasionally, sunlight triggered a reaction that strengthened a structure rather than weakened it. A molecule rearranged itself into a more efficient configuration. A boundary thickened where light touched it. These small, accidental improvements accumulated slowly, creating forms that could withstand the gentle presence of sunlight. Still, none of these creatures possessed purpose. They did not seek light, avoid heat, or pursue nutrients. They survived because their shapes allowed them to. They persisted because the world kept offering cycles that renewed them. Their boundaries were fragile scars of chemistry, their internal reactions flickers of order against a backdrop of disorder. But within these flickers lay the first hints of what life would eventually become. Systems capable of capturing and using energy, of organizing matter within themselves, of persisting long enough to influence their own futures. When these creatures divided, which they did only by the natural splitting of unstable boundaries, they did not create identical offspring. Fragments drifted away, carrying parts of the internal chemistry with them. Sometimes, a fragment contained enough structure to reform its cycle. Other times, it dissolved into the sea, its memory lost. But each fragment was a chance. Each division expanded the number of experiments the world could run. And with each experiment, the likelihood that some fragile cycle would persist increased. Storms altered these quiet populations with sudden force. Waves surged into shallows, breaking apart many of the early forms. Yet storms also delivered minerals from freshly eroded rock, supplying substrates that guided new assemblies. After each disturbance, most creatures would vanish, but the few that reassembled quickly became the ancestors of the next quiet generation. Their stability was not measured in days, but in cycles, each cycle reinforcing certain patterns, discarding others. The world above remained unaware of these silent beginnings. Skies churned with volcanic ash, oceans deepened, continents drifted without witness. Yet beneath this vastness, in places so small they could fit between grains of sand, life's first gestures continued. Their boundaries strengthened, their reactions became more consistent, the flow of energy within them grew more cohesive. These earliest creatures remained unnamed and unrecorded, known only by the persistence of their patterns. They did not leave bones. They did not leave fossils. They left only the memory carried in the living world that would follow the genetic whispers, the ancient cycles, the metabolic blueprints etched into every creature to come. They were the first storytellers not because they spoke, but because they endured. And in enduring, they taught the world how to weave continuity from the quiet chaos of chemistry. What rose from these unwritten forms was not yet recognizable, but it was already leaning toward life, toward movement, toward intention, toward the possibility of memory that would last more than a single tide. As ages drifted past in the unhurried pulse of tides and tectonic murmurs, the earliest creatures continued their quiet persistence. They remained unseen, uncelebrated, and unnamed tiny enclaves of continuity floating through oceans that did not yet know how to cradle life. Their boundaries quivered with fragility, their internal reactions trembled on the edge of collapse, and yet they returned, again and again, rising from chemistry each time the world smoothed their traces away. Their existence was not a triumph but a repetition, a gradual leaning toward stability in a planet still half-formed. Their forms were delicate, more suggestion than structure. Some resembled tiny spheres, their boundaries thickened by minerals embedded in their fragile membranes. Others stretched into irregular threads, their shapes dictated by the geometry of surfaces to which they clung. Still others drifted as small clusters, held together only by temporary bonds. Each form had its own rhythm, its own way of gathering the matter it needed to persist for one more cycle. In the shallows, where sunlight glowed faintly through a sky still heavy with vapor, certain creatures began to exploit the warmth in subtle ways. Sunlight did not nourish them, not yet, but it altered the pace of reactions inside their boundaries. Molecules moved with greater ease, shifting positions until they found arrangements that consumed or released small amounts of energy. Some of these reactions reinforced the stability of the boundary itself, making it slightly more resistant to dissolution when waves passed overhead. These changes were tiny, too small to be seen, too small to be named, but repeated across thousands of cycles. They began to matter. Lightless cracks beneath the crust fostered a different kind of resilience. Here, creatures learned to rely on gradients of heat and chemistry rather than the faint guidance of sunlight. Their boundaries formed in the dark, their reactions tuned to the slow, steady exhalations of the Earth's interior. Hydrogen sulfide, methane, and other reduced compounds floated through these cracks in gentle plumes. When these molecules touched certain internal structures, they triggered reactions that released measurable pulses of energy. These pulses were weak, inconsistent, easily lost, but they offered a hint of internal order, a flicker of metabolism that allowed some creatures to repair themselves more effectively than others. Meanwhile, in the porous walls of hydrothermal vents, within chambers no wider than the width of a hair, something subtler began to unfold. Early creatures that drifted into these mineral-filled cavities found themselves surrounded by catalytic surfaces that altered their internal chemistry. These surfaces accelerated certain reactions while slowing others, creating a delicate balance inside the boundaries of these beings. Reactions that would normally collapse into disorder lingered long enough to stabilize the creature's form. Some compartments developed loops of reaction that repeated with regularity, restoring internal structures even after minor disruptions. Though primitive and unstable, these loops represented the earliest hints of something that could heal, however clumsily. Not all creatures remained confined to these sheltered places. Some drifted outward with ocean currents, carried into regions where conditions were unpredictable. Many perished quickly, their boundaries dissolving into mineral-rich water. But a few survived the journey, not because they were strong, but because their structures were flexible. They adapted quietly, a boundary that thickened in response to salinity changes, an internal reaction that shifted pace when temperatures dropped, a pattern that reformed even after partial collapse. These creatures did not choose resilience, they embodied it by accident, shaped by cycles that rewarded what could last. As the oceans deepened and currents strengthened, more interactions occurred between drifting creatures. When two fragile boundaries collided, their contents sometimes mixed, producing new combinations of internal molecules. Most of these encounters destroyed both participants, dissolving their carefully gathered structures into the sea. But a few collisions generated systems that held together. Their boundaries merged, their internal cycles aligned. A new configuration emerged, one not present in either ancestor, but able to persist for a handful of cycles. These mergers were rare, but each added a new thread to the tapestry of early life, expanding the repertoire of what could exist. In tidal pools, where evaporation concentrated chemicals to near saturation, some creatures found themselves pressed against the edges of mineral surfaces. Here, dryness threatened their dissolution. But in these moments of strain, new possibilities appeared. Boundaries that incorporated certain lipids thickened enough to resist collapse. Internal molecules that aligned with mineral pores reassembled more quickly when water returned. These adaptations were not intentional. They were the result of which structures happened to survive the harshness of intermittent dryness. But each success, however small, nudged life's earliest forms toward the stability that would eventually define living systems. No creature in this era possessed memory in the way that life one day would. Yet there were patterns that repeated through cycles, shapes that reappeared after dissolution, boundaries that formed more consistently with each passing epoch. These echoes were not stored in molecules but in tendencies, the likelihood that certain structures would arise in the same environments again and again. The world was not yet writing genetic scripts, it was rehearsing them through repetition. Storms altered these early populations dramatically. A sudden swell could sweep entire communities of unwritten creatures into deeper water where pressure crushed their boundaries. Yet, as waves receded, new generations formed from the debris left behind. A volcanic eruption would heat shallow pools, destroying fragile structures but leaving behind minerals that altered the chemistry for the next cycle. Through these disturbances, life gained resilience not by resistance, but by renewal. The planet, unknowingly, cultivated robustness through impermanence. As millennia blurred into one another, more creatures developed cycles that allowed them to restore lost components. Internal reactions branched, creating networks capable of reassembling pieces of the boundary or regenerating simple catalysts. These were still fragile, easily undone by shifts in temperature or pH, but they represented a direction, a move away from chemistry's inherent instability towards something that could maintain itself even after disruption. The long dawn of unwritten creatures was not marked by progress but by persistence. A world that once held only drifting atoms now hosted delicate systems capable of continuity. They were small, they were vulnerable, they were silent. But for the first time in Earth's history, matter had begun to organize itself into beings that could outlast the conditions that created them. The dust of stars was learning not only to remember, but to remain. Time on this quiet planet folded itself into long repetitions, and within those repetitions, the earliest creatures refined the barest habits of life: to capture energy, to repair a rupture, to persist a moment longer than dissolution demanded. Their worlds remained pocketed and private between grains of sand, within the hollows of mineral chimneys, along thin films at water's edge, but those small theatres saw the most consequential rehearsals. Within them, networks of reaction deepened, chains that once broke apart now reassembled with surprising fidelity. Boundary films that had been porous and fickle thickened slightly as lipids and mineral fragments interwove, creating enclosures that buffered internal chemistry from the blunt forces of tides and storms. These enclosures did not think, they simply allowed. They allowed concentrations to climb, allowed reaction loops to recur, allowed brief flows of energy to be harnessed and passed along in ways that, over countless cycles, felt less accidental. Some systems developed internal redundancies, duplicate pathways that could restore a lost molecule or create a substitute when conditions removed a crucial piece. Redundancy was not design, but consequence. When several ways existed for a simple transformation to occur, systems that happened to include multiple routes were more likely to continue after perturbation. Thus, by the slow arithmetic of repetition, complexity accrued. The deep-dwelling forms near vents found a particular steadiness in chemical gradients. They learned, without intention, to position their fragile compartments where the flux of ions and electrons was most forgiving, where the plume's warmth met the cold sea in a thin, sustaining sheet. In these niches, reactions that stitched energy into usable forms, primitive proto-metabolisms, hummed with a faint regularity. Some enclosed systems developed loops that recycled intermediates. A molecule transformed, used, and then remade by the very chemistry it produced, like a small machine that fed itself enough to keep turning. These loops were inefficient and error-prone, but they were loops nonetheless, and any repeatable loop impressed a kind of temporal memory onto matter. Outside the compartments, catalysts embedded in mineral walls continued to supply structure, orienting reactions that might otherwise dissolve into chaos. The interplay between compartment and catalyst became a pattern repeated in many locations, a duet between confinement and surface that allowed fragile systems to be tested and sometimes to endure. On sunlit margins, different experiments unfolded. There, transient access to photons, hazy, scattered, insufficient for anything like full photosynthesis, nevertheless introduced fresh chemical permutations. Light could break bonds or create reactive intermediates that then participated in new syntheses. In shallow pools, brief photochemical reactions produced molecules that, when trapped within boundary films or between clay sheets, became building blocks for more elaborate internal pathways. Light was an occasional teacher, sometimes destructive, sometimes generous. Its intermittent lessons created varied opportunities for forms that could tolerate or even harness such energy. Creatures that persisted across day-night cycles acquired a provisional resilience to photic stress, their internal chemistries shifting rhythmically with the light's arrival and withdrawal. Encounters between creatures, collisions, adhesions, fusions played a quiet role in expanding possibilities. When two enclosed systems met, their internal chemistries could mingle, producing novel mixtures that neither had contained alone. Most such meetings dissolved everything into simpler parts, but occasionally a fusion produced a hybrid organization more robust than either antecedent. These hybridizations, rare and stochastic, created a loose genealogical web of early forms, a network in which innovations could spread across populations, not by inheritance in the genetic sense, but by successful transfer of stable configurations. In a world where nothing multiplied with fidelity, transfer and recombination offered alternative routes for novelty to propagate. Natural selection, so often pictured in dramatic terms, here looked like something delicate and quiet. The environment repeatedly favored matter that could persist through cycles of stress. Salt concentration after evaporation, a brief thermal pulse, a surge of chemical influx from the mantle. Any of these could cull fragile forms while leaving sturdier ones intact. Over long stretches, these small biases accumulated. The surviving systems occupied narrower niches, their chemistries tuned to local rhythms. Adaptation thus emerged as a statistical shaping, a sculpting by countless indifferent events rather than by foresight. No creature planned its improvements. They simply arose where persistence had been rewarded previously. Throughout all this, the ancient starlight, lodged in each atom, continued to whisper. Isotopic signatures and trace metals subtly altered reaction rates and binding affinities, nudging certain pathways to be marginally more probable than others. These microscopic biases mattered across the eons. A slightly faster reaction favored in one mineral context could, through repetition, become the backbone of a metabolic loop. The universe's long history, encoded in mass and charge, silently shaped the earliest tendencies of life on Earth. In that way, the first creatures were literally composed of memory. They embodied the story of stellar births and deaths through the elements that sustained them. They were small, they were slow, they left no bones, but through persistence and repetition, they began to weave continuity into matter itself. These unwritten creatures taught the planet a new habit, that structure could beget structure, that repetition could produce stability, that fragile organization could accumulate into systems capable of resisting obliteration for a time long enough to matter. And in the hush of vent chimneys, in the salt-tight rims of drying pools, in the mineral-lined veins under stone, the first storylines of life began to thread through the world, silent, patient, inexorable. Extinction did not arrive with thunder in the earliest ages. It came quietly, like a tide receding just beyond hearing. Long before the world knew forests or wings or bones, it learned the art of disappearance. The first creatures, those fragile gatherings of chemistry that hovered on the threshold of life, were as temporary as ripples on a tide pool. They formed, dissolved, reformed, and vanished again without witness. Yet each disappearance left behind something subtle, a change in the chemistry around them, a shift in the gradients that shaped their survival, a faint preference for certain patterns over others. Extinction was not yet tragedy. It was revision, the world's gentle way of clearing space for new configurations of matter. As the oceans stirred, carrying nutrients and minerals across their deepening basins, many early forms drifted into environments that did not favor them. A shift in salinity, a sudden cooling, the arrival of a volcanic plume, any of these could unravel the delicate boundaries that held their cycles together. When this happened, their components scattered into the sea, becoming raw material for other experiments. Their absence was not registered as loss but as opportunity. Where one pattern dissolved, another took its place. The world learned to refine itself through this unceremonious editing. Extinction, in these early eras, behaved like erosion. It smoothed the landscape of possibilities, removing unstable combinations and leaving behind those with even a slight resilience. In cracks beneath the crust, creatures dependent on narrow temperatures perished when convection shifted. In shallow pools, those unable to withstand the dryness of midday sun vanished by dusk. In vent systems, small shifts in chemistry extinguished entire microenvironments. Each disappearance left behind gradients altered just enough to favor different future forms. In this way, extinction sculpted the world's living chemistry as surely as tides sculpted shorelines. Some early forms retained their presence across several cycles, only to vanish when storms disrupted their environments or when a slow drift in ocean chemistry made their survival untenable. Their endings were silent, without witness or lament. Yet, through their loss, the planet adjusted its internal rhythms. Minerals dissolved differently, heat traveled differently, currents shifted patterns. Each extinction reshaped the world in ways too gentle to name, but too persistent to ignore. The absence of a form became as influential as its presence had once been. Extinction also occurred within the boundaries of early creatures themselves. Internal reactions faltered. Loops that once maintained delicate structures collapsed under energetic strain. A single missing catalyst, a broken chain, a destabilized boundary, all could bring an end to a fragile organism. These endings contributed not only to the ocean's chemistry, but to the quiet evolution of life's emerging logic. only systems capable of restoring themselves, of compensating for disruptions, could persist. The planet did not choose which forms endured. The conditions simply shaped the direction of continuity. In the darkness around hydrothermal vents, extinctions unfolded in waves. A plume might shift its position slightly, moving essential minerals a few centimeters away from the chambers where early creatures thrived. Without those minerals, internal cycles starved, boundaries weakened. Entire lineages vanished within moments. Yet as they dissolved, their molecular remnants flowed outward, seeding nearby pores with new combinations. Extinction and creation overlapped, each feeding the other. The planet's memory expanded through this interplay, accumulating new chemical possibilities through the dissolution of old ones. When tectonic forces shifted the seafloor, vent fields collapsed or sealed themselves. Creatures that depended on those fields disappeared entirely, leaving behind sediments that bore faint isotopic signatures of their existence. These sediments recorded the shape of their extinction not through fossils, but through chemical absence, missing gradients, altered mineral deposits, the subtle quieting of once active reactions. The world learned to tell the story of extinction not in bones, but in the softened echoes of chemical change. In sunlit shallows, extinction moved differently. Creatures that drifted toward shorelines sometimes found refuge in mineral-rich pools, but more often they perished as waves cast them into regions too variable to support delicate cycles. Yet these losses enriched the water with new molecules, enabling more robust forms to arise. Each disappearance strengthened the diversity of conditions under which life could persist, shaping the dawn of biological complexity through the quiet removal of what could not endure. Extinction was not a force separate from life. It was life's sculptor. It carved away what the environment would not support, leaving behind forms more suited to the cycles of heat, water, and stone. The planet edited its living story not with harsh lines, but with subtle erasures that opened space for new experiments. Over millions of cycles, extinction refined the world's earliest biological tendencies, pruning fragile patterns and allowing more stable ones to flourish, however modest their resilience. The earliest mass extinctions were unmarked, unmeasured. They swept through microbial populations long before the world had learned the vocabulary of bones or shells. They unfolded like a breath held too long, then released. These losses became part of the planet's memory, shaping its chemistry, enriching its oceans, guiding the emergence of systems with greater endurance. Extinction was not the end. It was the transition, a gentle editor giving the world permission to change. As time deepened into vast, unmeasured spans, extinction became a quiet companion to everything that lived. It remained gentle in these early ages, not a force of violence, but of dissolution. A shift in temperature, a change in mineral flow, a subtle alteration in salinity, each could unmake a lineage that had endured for countless cycles. But even in their unmaking, these early beings left traces. Faint chemical fingerprints drifting through the oceans, folded into sediments, or locked into mineral veins that would one day rise into mountain stone. These traces were not fossils, in the way later eras would know them. They were gradients softened by absence, quiet voids where certain reactions no longer occurred. The world carried these voids like the hollow spaces in a shell, negative forms that hinted at what once existed. When the chemistry of early oceans shifted through volcanic exhalations, through the slow cooling of the crust, through the rain's constant carving of minerals into water, entire populations of fragile creatures vanished. Their disappearance was not marked by struggle or resistance. It was simply the moment when their patterns could no longer be sustained. Yet, as they faded, new chemistries emerged to occupy the space they left behind. The planet did not mourn, it rebalanced. It refined its memory through removal as much as through preservation. At the edges of hydrothermal vents, extinction moved like a soft tide. Vents flickered in intensity, warmed or cooled by the shifting mantle beneath them. When they cooled too far, the energy gradients that sustained early metabolisms dwindled. Boundaries weakened, loops unraveled, structures dissolved. But remnants of these creatures drifted into neighboring chambers, where slightly warmer plumes kept new experiments alive. Extinction here did not erase completely. It redistributed. It took apart the old and scattered its pieces into environments more suited for renewal. In shallow pools, drying cycles played a similar role. A pool that had once nurtured a thriving microcosm could evaporate within days during a warm spell, leaving behind crusted salts and the fragile remains of its inhabitants. These remnants, rehydrated by the next rainfall, seeded nearby pools with new chemistries. Extinction became a kind of migration, a gentle dispersal of possibilities. The world learned that loss could carry memory outward rather than bury it entirely. Even far from vents and pools, drifting forms met extinction simply by encountering regions incompatible with their fragile existence. Some drifted into waters too acidic, others into waters too cold or rich in metals. These zones acted as boundaries, not through hostility but through indifference. They dissolved what they could not support. Yet these untold endings enriched the waters with new molecules, altering the background from which new forms would emerge. In this way, extinction was not a barrier, but a gradient, one that shaped the pathways life could take. There were moments, scattered across millions of years, when extinction swept across entire oceans. These events were not sudden. They unfolded over long intervals as the atmosphere thickened or thinned, as continents shifted, as the chemistry of the planet leaned in new directions. Oxygen, once scarce, began to appear in trace amounts, created by early photosynthetic metabolism. For many anaerobic forms, even a whisper of oxygen spelled dissolution. Their extinction wrote a new chapter in silence, easing the rise of creatures that could tolerate or use this strange reactive gas. What vanished made space for what could adapt. Extinction thus acted as the world's earliest editor, refining the narrative of life not by selecting for strength, but by removing what no longer aligned with the shifting environment. It clipped fragile threads before they could tangle too deeply. It erased unstable lines so that more steady ones could take root. Without this gentle editing, early life would have drowned in its own experimentation. Instead, the planet adjusted its story slowly, one disappearance at a time. Sometimes extinction occurred at the level of a single lineage, disappearing quietly without altering the broader world. Yet even these small erasures left a chemical echo. A particular molecule that had once been abundant might fade from common reaction cycles. A pattern that once dominated a shallow pool might vanish, replaced by another that happened to withstand the changing tide. Over epochs, these subtle transitions accumulated until the very nature of life shifted. Extinction smoothed the path of evolution long before true evolution existed. When tectonic plates collided or drifted apart, the oceans themselves changed shape. Entire vent fields vanished into subducting crust, taking with them communities of early creatures. New fields emerged in fresh fractures, inviting new forms to take shape. Extinction here was cyclical, woven into the fabric of geology. What disappeared beneath the crust returned later, as minerals released in volcanic plumes, feeding new chemistries above. The earth recycled its own losses, transmuting the memories of vanished life into ingredients for future experiments. The earliest mass extinctions, the ones that erased entire metabolic strategies, left deep chemical signatures in the oceans. Ratios of isotopes shifted, the distribution of minerals changed. Conditions that had once favored one kind of metabolism now favored another. These shifts did not merely extinguish, they redirected. Life began to lean toward pathways more compatible with the world's evolving atmosphere, gradually aligning with patterns that would endure for billions of years. Through all of this, extinction never acted as a final door. It acted as a gentle turning of the page, allowing the world to write and rewrite its living story. Without it, early life would have remained chaotic, fragmented, endlessly lost to cycles that led nowhere. With extinction's quiet guidance, patterns thickened, memories deepened, continuity took root, and in the spaces left behind by what vanished, the planet found room to imagine something new. The world, still young in its deep chronology, learned to revise itself through absence. Extinction, once a small ripple in the chemistry of ancient oceans, gradually became a structural force, silent, patient, unhurried. It did not arrive as catastrophe. It arrived as forgetting. A lineage that had woven its cycles through warm shallows would someday find the salinity shifting beneath it, or the minerals altering so slightly that its fragile boundaries no longer held together. The forms dissolved, their stories unspooled into chemistry again. Yet the world did not dim. The dissolution fed new reactions, supporting novel combinations that had been impossible, while the older patterns still prevailed. Loss made space, and space made possibility. Creatures that lived in the warm darkness of vent fields faced their own erasures. A shift in the flow of superheated water could unmake entire communities that had persisted for millennia, but even this loss was gentle in its effect. Their components drifted into adjacent chambers, re-entering the intricate gradients of heat and mineral that fed the next generation of experiments. Extinction in the deep ocean resembled sediment. Even as it sank, it became part of the foundation for what rose above it. Life advanced not through dominance, but through relinquishment, each disappearance smoothing the way for different strategies to take hold. As the planet's interior cooled and tectonic cycles grew more intricate, large portions of the seafloor plunged into subduction zones. Entire ecosystems dissolved into magma, their chemical signatures released later through volcanic exhalation. Though the creatures themselves were gone, their memories scattered into gases, metals, and isotopes returned to the oceans and atmosphere in altered form. Each re-emergence hinted at cycles far larger than any single lineage. Extinction, woven into geology, ensured that ancient life always contributed to future life, even if the contribution was disguised as mere mineral. Gradually, oxygen began to accumulate in the shallowest waters, produced by early photosynthetic organisms that threaded sunlight into chemical energy. This shift was invisible at first, diluted into the vast ocean. But over time, oxygen's sharp reactivity began to unmake some of the planet's oldest metabolisms. Systems that relied on chemical environments devoid of oxygen slowly vanished as their boundaries faltered and their internal cycles destabilized. What had once been universal became niche. What had once been stable became vulnerable. Extinction swept through these early anaerobic forms with softness, not violence, as the world leaned toward a new chemistry. Yet even oxygen's quiet arrival did not produce a blank slate. Some of the disappearing forms left subtle legacies, enzymes that tolerated trace oxygen, reaction loops that accommodated small oxidative shifts. These legacies were carried by surviving lineages, then refined through countless cycles until oxygen, once a threat, became a resource. Thus, the world's first great chemical shift was shaped not just by the rise of new life, but by the absence of old life. Extinction edited the narrative, softening the past to make room for the coming age of breath. In shallow estuaries, early communities faced extinctions driven by tides that swelled unpredictably. Storms thickened the water with sediment, blocking sunlight and collapsing the metabolisms of organisms that relied on its faint glow. When the sediment settled, the pools were altered saltier, richer in minerals, more favorable for different forms. Extinct lineages left their traces in these altered conditions. Sometimes a molecule they produced lingered long after their disappearance, subtly enriching the environment for the next wave of life. Extinction, even here, acted as a quiet hand smoothing the edges of possibility. Not all losses were large or transformative. Many were small endings, a single lineage dissolving in an isolated pool, an isolated cluster failing to reassemble after a freeze, a boundary rupturing during a sudden shift in pH. These small extinctions accumulated, gradually pruning chemistries that were too fragile to persist. The survivors of these cycles inherited the landscape shaped by these losses. Oceans with slightly different mineral balances, crusts with new deposits, atmospheres shifting slowly toward composition that future organisms would rely on. Each extinction refined the world's template. Occasionally, extinctions layered upon one another, producing long, quiet periods when diversity seemed to shrink rather than expand. These intervals did not halt life's progress, they clarified it. With fewer forms occupying the chemical landscape, a handful of lineages explored broader regions of possibility. Their metabolisms diversified, their boundaries strengthened, their capacity for replication gained coherence. In pruning the early tree of life, extinction made the surviving branches more defined. As the planet stabilized further, oceans stratified into layers with differing temperatures and chemistries. Lineages that strayed from their preferred layer vanished, replaced by forms better suited to the gradients. These extinctions created invisible borders, zones where certain metabolisms thrived and others dissolved. Such borders would later shape migrations, ecosystems, and the very architecture of biological diversity. But in these early times, they simply reflected another gentle revision. Life flowing along paths of least resistance, guided by the quiet hand of removal. Even meteor impacts, those distant harbingers of catastrophe in later ages, brought only a soft kind of extinction to the earliest world. Their fragments altered chemistry, cooled oceans, or shadowed skies, but life at this stage was diffuse, numerous, and sheltered in deep environments. Extinction from these impacts resembled a shift rather than a scouring, the fading of certain pathways, the strengthening of others. Loss redistributed memory into new shapes. Throughout these eras, extinction acted not as opposition to life, but as its refinement. It gave the world structure through absence. It shaped possibilities by erasing what could not endure. It helped emerging lineages align with the planet's evolving conditions. Without extinction, life would have sprawled without coherence, its experiments too numerous and unstable to find direction. With extinction, the map of possibility narrowed just enough for continuity to take hold. What vanished shaped what remained. What remained carried forward the quiet lessons of loss. And through that exchange, gentle, slow, inevitable, the world moved closer to the complexity that would one day fill its oceans and skies. As the planet circled its young sun through ages without names, extinction continued its quiet authorship. Life grew more intricate, yet its foundations remained vulnerable. The earliest creatures drifted through waters that shifted endlessly in temperature, chemistry, and clarity. Their existences were tenuous, anchored to cycles of energy and mineral that could shift without warning. And when those shifts came slow or sudden, entire branches of possibility dissolved back into the world that formed them. Extinction did not announce itself. It unmade the fragile simply by allowing the environment to change. Loss remained the planet's most patient instrument. Oceans continued thickening with memory. Minerals seeping from volcanic ridges altered the composition of water, gently favoring some metabolisms while limiting others. When the balance tipped, creatures that once thrived found themselves unable to maintain their internal cycles. Their boundaries weakened, their reactions slowed, and they faded into chemical silence. This fading was not violent. It was as soft as a page worn away by time. Yet in their absence, the oceans shifted again, slightly enriched by what they left behind, slightly emptied of what they once maintained. Extinction became an editor, trimming complexity in one place so it could emerge with new clarity elsewhere. In deep waters near vent fields, extinctions unfolded like subtle changes in breath. A plume that once delivered steady warmth might weaken, cooling the chambers where entire communities had nestled. Without the heat that sustained their energy flows, these creatures lost their tenuous equilibrium. Their boundaries folded inward, their internal rhythms faltered, and they dispersed. But their remnants, tiny fragments of molecules, stray catalysts, mineral-bound traces entered neighboring pores and veins, influencing chemistries that had not existed before. The world learned to incorporate loss, folding it into future potential. As oxygen levels crept upward, still low by later standards, but enough to stir subtle shifts, extinction touched lineages that had existed unchanged for millennia. Oxygen's quiet intrusion altered the chemistry of oceans, oxidizing minerals, reshaping gradients, and destabilizing ancient metabolic pathways. Entire groups of organisms that had once dominated the early seas vanished without drama, not because they were flawed, but because their world had gently moved on. Yet their disappearance accelerated the rise of forms better suited to the presence of this reactive gas. Extinction shaped evolution not through violence, but through the planet's slow lean toward a new atmospheric balance. Tidal pools offered a different kind of erasure. With every cycle of wetting and drying, life assembled and disassembled itself. Pools that nurtured entire populations during cool mornings might evaporate by noon, leaving behind cracked patterns of salt and organic residue. When rain returned, these residues dissolved, carrying the chemical signatures of lost lineages into adjacent pools. Extinction here became diffusion. a spreading of memory outward, a recycling of the past into new experiments. Nothing was destroyed completely. Each loss softened into the next beginning. Even the earliest photosynthetic forms, which gradually transformed the atmosphere, faced extinctions of their own. They were delicate, easily overwhelmed by sediment, darkness, or sudden chemical shifts. Their diminishment made space for new variants, ones that tolerated higher oxygen, or adapted to deeper water, or developed pigments adjusted to different wavelengths of light. Extinction refined these lineages, allowing photosynthesis to diversify rather than collapse under its own instability. It acted like a quiet gardener pruning shoots that grew too thin, ensuring that stronger branches could take shape. Continental movements exerted a slow but profound influence on extinction. As tectonic plates drifted, shallow seas vanished, replaced by deeper basins or exposed land. Ecosystems that had persisted for eons disappeared simply because the geography beneath them shifted. Yet these geological transitions created new coastlines, new vent fields, new gradients, where life's chemistry could explore unfamiliar arrangements. Extinction, linked to the movement of stone, intertwined with creation. The world offered new canvases for life each time. Old habitats faded into silence. Some extinctions rippled globally, though nothing yet possessed the anatomical complexity to leave a dramatic fossil trace. The earliest atmospheric shifts, fluctuations in methane and carbon dioxide, caused oceans to warm or cool in ways that altered global chemical cycles. Metabolisms that once thrived in nutrient-rich waters struggled when currents changed. Others surged in their place, discovering new footholds as the planet inhaled and exhaled through epochs. Extinction acted here as a reset, not a purge, an invitation for new forms to explore spaces abandoned by their predecessors. Even the rise of early genetic systems, rudimentary, unstable, error-prone, brought layers of disappearance. Mutations introduced pathways that faltered. Replication errors erased lineages before they could take root. But each failure enriched the chemical environment with fragments that contributed to better systems. Life improved because so much of it did not survive. Extinction became the quiet quality control of evolution, a soft filtration through which only the most self-sustaining patterns emerged. There were no catastrophes in these early ages, not in the way later ages would know them. No asteroid shadows, no volcanic winters shutting skies, no rapid collapses of forests or reefs. Instead, extinction modeled itself after time, slow, patient, certain. It shaped the world with the lightest of touches. It softened the edges of early life, erasing what the planet could not yet support and allowing what it could to settle into form. In the hollow spaces left behind by the lost, the planet found clarity. In the dissolving of the fragile, the durable took shape. And through these quiet revisions, life stepped further from chemistry and closer to coherence. As the planet aged into its slow maturity, extinction remained a constant presence, neither cruel nor kind, simply patient. It moved through ecosystems still too simple to carry names, touching lineages that had persisted for millions of cycles, dissolving their patterns back into the oceans that once shaped them. In this era, life had no memory beyond chemistry, no stories beyond the loops that allowed continuity. Yet, extinction acted as an unseen editor, smoothing the narrative by removing what drifted too far from harmony with the world's shifting conditions. Life did not resist this editing. It absorbed it, allowing absence to carve the path for presence. Across the oceans, new gradients emerged as currents strengthened and climates warmed. Some lineages spread briefly, finding advantage in altered chemistries, only to vanish when the world shifted again. Their disappearance enriched the water with molecules they had once stored internally, seeding new reactions in distant basins. These reactions birthed forms that bore faint resemblances to the vanished ones, as though memory persisted even after the creatures themselves had dissolved. Extinction's hand was soft yet deliberate. It trimmed the excess, refined the possible, and coaxed life toward greater coherence. When oxygen concentrations rose further, the shift invited another wave of disappearances. Entire memories of metabolism, ancient strategies forged before light shaped the world, faded into obscurity. Yet their disappearance left a profound imprint. Sediments recorded the transition, locking away iron-rich layers that signaled oceans once starved of oxygen. These layers became bookmarks in the planet's chronicle, pages where entire worlds had ended quietly so that others might begin. Extinction did not erase the past, it folded it into stone. Tectonic rhythms continued their cycle of creation and loss. New volcanic islands formed, offering fresh surfaces for colonization. Others sank beneath the sea, taking with them the fragile communities that had clung to their shores. But even in these vanishings, life gained something. Erosion carried minerals into the ocean, deepening nutrient cycles. Lightning over new landmasses created fresh atmospheric chemistry. Hydrothermal systems rose and fell, each disappearance opening a niche elsewhere, inviting new lineages to try again. Extinction redistributed possibility across the planet. Occasionally, entire ocean regions fell silent. Currents stalled, nutrients sank, light dimmed beneath volcanic ash. In these intervals, populations dwindled until only a few resilient forms remained. But the silence that followed was never empty. It was preparatory. As conditions improved, the survivors chosen only by chance and compatibility spread into the emptiness left behind. They diversified, not through intention but through the absence of competition, filling niches that had been cleared by extinction's patient brush. Diversity bloomed in the wake of silence, as though life inhaled sharply after a long-held breath. Even the genetic systems that had begun to stabilize faced the quiet sculpting of extinction. Errors in replication created fragile variants that persisted briefly before dissolving. Others introduced slight strengths, boundary molecules that held together more consistently, catalysts that accelerated essential reactions, threads of information that endured despite environmental strain. These small improvements spread through populations as less stable forms faded away. Extinction acted as a sieve, allowing only those patterns capable of maintaining themselves to shape the future. Through these ages, the world never hurried. Loss did not rush, gain did not leap. Everything unfolded with the rhythm of geological time, a long, slow settling of what could survive. Extinction, far from ending life, defined its boundaries. It revealed which pathways were durable enough to anchor continuity. It cleared overcrowded chemical landscapes, opened silent spaces where new strategies could take root, and ensured that life did not stagnate in narrow corridors of possibility. Without extinction, early life would have sprawled endlessly, tangled in its own instability. With it, life moved forward with subtle intention, guided by the absence of what could not endure. And though the creatures of this era possessed no consciousness, no memory but the repetition of their own cycles, they carried something profound within them. The inheritance of every lineage that had come before. Every disappearance fed the survivors. Every loss shaped the next beginning. Every quiet erasure refined the architecture of life. Thus, the planet learned to write its living story, not with pen or with flame, but with removal, a gentle editing of the world's unfolding dream. Extinction, soft as a shadow, ushered life toward clarity. Awareness did not burst into the world as revelation. It gathered softly, slowly, like light remembering how to touch the surface of a long, dark sea. Intelligence was not a crown placed upon life, but a continuation of the same quiet processes that once folded carbon into spirals, once coaxed fragile cycles to persist in warm shallows, once sculpted vast ecosystems through extinction's gentle hand. Mind, when it finally emerged, was only the universe reorganizing itself into a new shape, one capable of holding memory differently. Where early creatures remembered through pattern, through chemistry, through repetition, later beings remembered through thought, an echo of the cosmos, learning to see its own reflection. In the ancient oceans, long before any creature had eyes, the world rehearsed the foundations of intelligence. Networks of cells shared signals. Faint currents of information passed between membranes. Some signals coordinated movement, others guided the search for energy. These gestures were not thought, not anything resembling intention, yet they laid the groundwork for systems that would one day translate chemical gradients into sensation, then sensation into meaning. Life learned to sense long before it learned to understand. Sensation was its first language, its earliest way of mapping the world. As organisms grew more complex, these signals intertwined into threads of continuity, neural precursors carrying electrical whispers through fragile bodies. These whispers were echoes of older forces, charge separation born in hydrothermal vents, electron exchanges sculpted by minerals, the breath of ancient stars encoded in every atom involved in these reactions. Intelligence grew from this inheritance, not as a departure from the universe's past, but as a continuation of it. Thought was made from the same particles that had once drifted silent through interstellar clouds, carrying isotopes forged in supernovae. The world did not notice when the first hints of awareness stirred. Somewhere in the dim shallows, a creature reacted not merely to light, but to the memory of light. Somewhere beneath the shifting canopy of an early forest, a nervous system connected sensation to anticipation. These were small awakenings, barely distinguishable from instinct, but in these moments, the universe was beginning to observe itself, however faintly. The eyes that would one day gaze at the stars were forming beneath the same sky whose dust had shaped them. Memory deepened, not the chemical memory of the earliest forms, nor the geological memory of stone, but something more fluid memory that moved within minds, that rippled across generations through behavior, learning, and imitation. Minds began to store impressions of landscapes, patterns of seasons, the presence of danger, the promise of nourishment. These impressions shaped survival, but they also shaped awareness. Through memory, creatures learned to carry a fragment of time with them. They became vessels of past and future, shaped by both. Communication followed. Signals evolved from simple pulses into complex exchanges, choruses sung across oceans, gestures embodied in movement, scents drifting through forests, each carrying fragments of information that allowed one mind to influence another. These exchanges served survival at first, but they also introduced something new: connection. Through communication, the world's emerging intelligences began to weave themselves into networks that reflected, in miniature, the cosmic webs of matter that had shaped them. As minds grew, they carried within them the entire story of the universe, though they did not yet know it. The carbon that structured their bodies had formed in the hearts of stars. The calcium in their bones came from supernova ash. The iron that coursed through their bloodlines had once been the molten core of collapsing giants. Their thoughts, though intangible, were anchored in elements older than the world itself. Intelligence was not an anomaly. It was a late chapter in a long cosmic narrative. When the first beings gazed upward, truly gazed, not in reflex but in wonder, they unknowingly completed a vast and ancient loop. They saw lights scattered across darkness, unaware that those lights were their own origins. Hydrogen burning quietly in distant suns, heavy elements forged in explosive deaths, dust drifting through cosmic silence. These processes had shaped their bodies long before their minds began shaping questions. Awareness had returned to its source, not externally, but through the quiet realization that the night sky held something familiar. Intelligence did not emerge as mastery. It emerged as reflection. Minds became mirrors, in which the universe could see its own processes, slowed, softened, interpreted. Thought allowed the cosmos to contemplate time, to imagine distances beyond the horizon, to wonder about its own beginnings. Every curiosity was a continuation of the first chemical tendencies that drove molecules to assemble. Every insight was an echo of the earliest cycles that stabilized life. Even as species rose and fell, awareness deepened. Extinction continued its gentle editing, guiding which forms of intelligence could survive. Some lineages carried great potential but perished before their minds could bloom. Others adapted, shaping new strategies for perception, memory, and cooperation. Through each transition, the world refined its ability to reflect upon itself. Slowly, across epochs, one lineage emerged, whose minds grew vast enough to hold both memory and imagination. These minds learned not only to sense the world, but to question it. They shaped tools, constructed shelters, painted meanings into stone, and discovered fires that reminded them of the stars from which their atoms came. They named constellations without knowing they named their own ancestry. They studied shadows and cycles, learning the slow rhythms of the earth that had shaped their evolution. And eventually, One question rose softly, like a tide touching land for the first time. What if Earth once knew something and forgot? A question shaped from the very stardust that once drifted silent through darkness. A question that carried the resonance of everything that had ever been lost and everything that had ever endured. Awareness widened its circle slowly, like a ripple expanding across a still lake. As minds gained depth, they began not only to sense the world, but to contemplate it, to see patterns in tides, in seasons, in the slow drift of clouds. These early contemplations were not yet theories or stories. They were quiet recognitions, moments when the world felt connected in ways its creatures could not articulate. A sudden shift in the wind might stir a memory of past storms. A glimmer of starlight might echo something ancient within, though no lineage yet knew why the night sky felt familiar. Intelligence grew not through leaps, but through the accumulation of these small recognitions. Neural networks expanded, weaving pathways that mirrored the branching of rivers, the filaments of lightning, the tendrils of roots underground. These pathways allowed the world's creatures to store more of their past, to forecast more of their future, to develop a sense of continuity beyond instinct. The first true memories, ones that lingered beyond a single season, emerged in these networks. They were fragments, impressions, simple lessons carried from one dawn to the next. But they marked a turning. Life had begun to write its story not only in chemistry but in thought. From these memories arose behaviors shaped by reflection. Creatures gathered in groups for safety, not through instinct alone but through learned experience. They communicated changes in weather, dangers in their environment, opportunities for nourishment. Their signals grew more precise, their connections deepened. In these small exchanges, calls, gestures, shared movements, the first flickers of understanding appeared. Life was beginning to think together. Minds grew more spacious with each generation. Some creatures developed the ability to solve problems, to manipulate objects, to explore possibilities in ways that extended beyond immediate survival. Their intelligence remained modest by future standards, but it held a profound significance. The universe had begun experimenting with the ability to consider itself. Every thought was another layer of reflection, another fold in the cosmos's long memory. Meanwhile, the world around them changed. Forests spread across continents. Oceans deepened and warmed, skies cleared, revealing patterns of stars that had always been present, but rarely witnessed with clarity. Creatures with eyes began to see farther. Creatures with memories began to wonder longer. The night sky, once a backdrop, became a landscape of meaning, though its meanings were still instinctive, still wordless. Something in the light of the stars resonated with the chemistry of life, as if the atoms within living bodies remembered where they came from. Intelligence did not seek domination. It sought coherence. It searched for connections between sound and movement, between cause and consequence, between the rhythms of life and the rhythms of the world. Some creatures developed rituals, repeated behaviors that brought structure to their lives. Others explored curiosity itself, touching, tasting, observing without immediate purpose. Curiosity was the universe looking back at itself, examining its own arrangements with gentle fascination. Through curiosity, awareness deepened. Minds learned to map not only the world outside but the world within. Emotions formed simple at first, then more intricate, guiding choices, shaping interactions, binding communities. These emotions were extensions of ancient chemical gradients, now refined into signals that pulsed through living beings with meaning. Fear was the echo of early reactions that recoiled from harm. Joy was the resonance of cycles that had once found stability in warm, welcoming environments. Memory and emotion wove together, giving intelligence texture, as languages began to form not in words yet, but in shared calls and gestures. Something remarkable happened. Knowledge could outlive an individual. A lesson learned in one lifetime could be carried into the next through imitation. The world had discovered a new kind of inheritance, one not bound to molecules but to culture. The first stories emerged in this era, though they were simple, grounded in survival and the rhythms of nature. But they were stories nonetheless, threads of remembered experience, woven into collective understanding. And gradually, through these stories, the the world's creatures began to see themselves not as isolated beings, but as part of a larger tapestry. They recognized the patterns of migration, of changing seasons, of birth and loss. They sensed that existence had a shape. They sensed that they, too, carried a shape within them, a shape inherited from the stars, from the oceans, from the stone beneath their feet. When early humans appeared fragile, curious, unassuming, they entered a world already rich with silent memory. Their minds, more spacious still, carried the same dust that had shaped volcanoes, oceans, and forests. Within them, the cosmos found a new vessel for reflection. Humans gazed upward and saw not merely points of light but distant fires. They saw patterns in the sky and assigned them meaning. They wondered about beginnings, about endings, about their place in a world that had existed long before them. Their questions were the natural result of a universe folding back upon itself, seeking coherence across scale. For in their minds, the stars began to remember, not through light or gravity, not through isotopes or supernova winds, but through thought, through curiosity, through the quiet ache of wanting to understand. Human intelligence did not appear as triumph. It appeared as longing, a longing to trace origins, to understand the silence, to listen for echoes older than memory. This longing carried forward the earliest impulses of life, the search for energy, for connection, for continuity. But now it stretched across the cosmos, reaching towards stars that had forged the very atoms of the questioning mind. And as humans watched the night sky, wondering what lay beyond, they unknowingly completed a circuit billions of years in the making. Stardust contemplating stardust, the universe perceiving its own remnants through the mirror of awareness. As human minds deepened, awareness grew layered. Thought no longer drifted like a lone current through the body. It branched, intertwined, circled back upon itself. Humans remembered not only events but meanings. A sunrise became more than light, it became renewal. A river became more than water, it became continuity. A night sky became more than darkness, they felt it as a threshold, a vastness that stirred something ancient in their bones. The universe had spent billions of years scattering its elements across space, shaping planets, sculpting oceans, nurturing life. Now, through human thought, it gathered itself again, quietly in memory, in imagination, in wonder. Humans began to build stories around the world they saw. These stories were early mirrors, reflecting their growing understanding of nature's rhythms. They spoke of origins not because they knew them, but because they sensed that everything must have a beginning. They traced patterns in the movement of herds, in the changing colors of leaves, in the cycles of the moon. Story by story, they taught one another how to see, how to feel the world's underlying coherence. These stories were not scientific, yet they carried a truth older than method, that the world was connected, that existence had shape, and that humans were woven into that shape. Their minds, still new to reflection, turned inward as often as they turned outward. They began to sense the mystery of consciousness itself, the strange experience of having thoughts that rose and fell like tides, of holding images of things not present, of feeling echoes of events long past. In those moments, humans encountered something no earlier creature had known, the ability to witness their own witnessing. The universe had grown internal eyes. Through these internal eyes, humans began to remember the world differently. They saw in stone the passage of time. They saw in fire the breath of ancient stars. They saw in each other the fragile persistence that had carried life across impossible distances of history. The recognition did not arrive all at once. It came in small moments. The awe of watching lightning split the sky, the humbling silence that followed a storm, the sense that life, even in its hardships, was part of a larger unfolding. As human societies expanded, intelligence accumulated not only within individuals but across generations. Knowledge became communal, memories extended beyond lifetimes, skills passed from parent to child, from elders to the young, from one village to the next. This continuity of knowledge was a new kind of inheritance, far faster than evolution, far more flexible than instinct. Through it, the universe began composing thoughts over centuries rather than seconds. Curiosity widened with each generation. Humans watched the movement of stars with a reverence that bordered on instinct, as though something in their bloodline recognized the distant light. They began to mark the passage of time by the alignment of celestial bodies. They gave names to constellations, not realizing that naming was a form of remembering, a way of capturing flickers of cosmic origin in sound. They drew sky maps on stone, tracing patterns whose meaning they could feel but not yet explain. Through these acts, humans carried forward the memory of the stars, not consciously but through a deep resonance that pulsed beneath language. It was the resonance of iron forged in supernovae, of calcium shaped in dying suns, of carbon spun in stellar winds. The atoms that built human hands now pointed toward the sky from which they came, recognizing something essential in the distant flicker of light. With time, humans grew to ask questions about the nature of existence. These questions were not just attempts at explanation, they were reflections, the cosmos contemplating its own architecture. What is life? What is death? What lies beyond the horizon? Why does the night sky feel both familiar and unreachable? Each question contained echoes of earlier epochs, when chemistry first leaned toward life, when early creatures sensed without understanding, when extinction reshaped what could be. Intelligence evolved into self-awareness, and self-awareness evolved into wonder. Wonder was the softest expression of the universe, remembering itself. It guided humans to look beyond their immediate needs, to reflect on causes and consequences, to imagine worlds beyond their own. Through wonder, the cosmos extended its memory far into possibility. Human minds became repositories of time. They carried the accumulated stories of ancestors, the lessons of survival, the interpretations of the world's rhythms. They observed not only what changed, but why it might have changed. They linked patterns across seasons, across generations, across regions, and in doing so, consciousness became a tapestry, woven from biology, stitched with memory, threaded with starlight. Eventually, humans developed the ability to look deeper into the nature of matter. They learned that the elements composing their bodies had origins long before Earth existed. They discovered that the iron in their blood came from supernova explosions, that the oxygen they breathed was the legacy of ancient stars, that the carbon at the core of their being had drifted through space before becoming part of oceans and forests and living flesh. With each discovery, the loop tightened. The stars were not distant strangers, they were family. And as humans grasped this connection, something shifted in the way they understood themselves. They were no longer merely observers of the cosmos, they were participants. They were the universe experiencing its own evolution through the medium of thought. They were memory given shape, awareness given voice. They were the continuation of a story written in light, in dust, in the patient unfolding of time. Yet even with all their inquiry, all their discovery, one question remained, echoing softly through the chambers of human thought. The question that opened the door to this meditation. What if Earth once knew something and forgot? A question shaped from the stars, carried through oceans, breathed by forests, and whispered now by minds made of ancient light. As human awareness deepened, thought reached a new threshold, the ability not only to wonder about the world, but to wonder about wonder itself. Consciousness folded inward, then outward again, creating layers of reflection that stretched across landscapes and generations. Minds now carried questions that felt older than language, questions born from the chemistry of early oceans, from the patience of tectonic stone, from the long silences of the night sky. These questions were not merely intellectual, they were ancestral, woven into the very elements that built each neuron, each heartbeat. Humans began to see patterns in their own thinking. They recognized that emotions rose and fell like tides, shaped by forces within and beyond them. They noticed that ideas emerged from quiet spaces, moments of stillness, when the mind loosened its grip on the world. They sensed, without fully understanding, that their thoughts were extensions of something broader than themselves. The universe, through them, was practicing introspection. Communities formed, bound not only by survival but by shared meaning. Around fires, humans told stories that linked earth and sky, life and death, past and future. These stories stitched countless moments into threads of continuity. They transformed memory into legacy. They turned experience into understanding, and through them, intelligence became a collective phenomenon, no longer confined to individual minds. Thought flowed between people, like wind through trees, carrying fragments of insight from one generation to the next. The more humans reflected, the more they noticed the strange duality of their existence. They were at once temporary and timeless. Their bodies would fade, yet the elements composing them would return to soil, to water, to atmosphere, joining cycles older than life itself. Their ideas, too, flowed beyond their own lifespans, carried through teachings, traditions, inventions. In this blend of transience and persistence, humans sensed a mirror of the universe's own nature. Stars burned out, yet their remnants seeded new worlds. Species vanished, yet life continued. Civilizations rose and fell, yet intelligence remained. Over centuries, humanity's curiosity matured into inquiry. Inquiry rose into science. Science became a way of listening to the world, of asking questions so carefully that the universe, in its quietness, revealed a few answers. Humans learned to measure the age of rocks, to decipher the chemistry of stars, to unravel the delicate structures of life. With each discovery, they moved closer to understanding the cosmic story that had shaped them. Yet the more they learned, the deeper the mystery grew. Knowledge did not shrink the unknown, it expanded it. The horizon of ignorance receded, only to reveal broader expanses of questions, and in that expansion, humans found humility. They realized that their intelligence was not the pinnacle of existence, but a single expression of a much older creative process, one that began in collapsing stars and drifting dust. Still, humanity searched. Telescopes reached outward, microscopes reached inward. Equations mapped the invisible threads of gravity and light. Observations traced the movement of galaxies, the behavior of particles, the unfolding of life. Each discovery added another layer of reflection, another fold in the universe's ongoing contemplation of itself. Minds made from stardust were uncovering the paths of stardust. Awareness, born from ancient fire, was tracing that fire's ancestry. And yet, with all this knowledge, the world remained filled with unanswered questions. Humans could describe the structure of atoms, but not fully grasp why matter gives rise to consciousness. They could trace the evolution of species, but still wonder why the universe permits life at all. They could measure the age of stars, but not explain why beauty stirs something profound in the human heart. These unanswered questions were not failures. They were invitations, gentle reminders that intelligence is part of a mystery far larger than itself. Through this growing awareness, humans began to sense that they were connected not only to the past, but to the future. Their decisions shaped ecosystems, climates, and even the trajectory of life on the planet. This responsibility felt heavy at times, yet it also brought clarity. To think was to participate. To reflect was to contribute. To imagine was to extend the universe's memory into new possibilities. As minds grew bolder, some humans turned their attention back to the stars, not merely as lights in the sky, but as origins. They asked, "What are we made of?" And the universe answered through spectra, through isotopes, through the faint glow of cosmic background radiation. The answer was simple and profound. Humans were made of the same elements forged in ancient stellar furnaces. Their bones, their blood, their breath all carried the signatures of supernovae. Every thought was shaped by particles older than Earth itself. This realization transformed the human view of existence. The cosmos was no longer distant. It was intimate. It lived within every atom of the body, every flicker of thought. Humans were not separate from the universe. They were expressions of it, brief, luminous flares of awareness rising from cosmic memory. And so, as humanity looked upward, contemplating the stars, they were also looking inward, contemplating themselves. The boundary between outer and inner blurred. Reflection became a loop, one that echoed across the ages, one that whispered a quiet truth. The universe remembers through us, not as destiny, not as purpose, but as continuity. And beneath all this reflection, one question returned from the beginning of time, soft as breath resting on a quiet night. What if Earth once knew something and forgot? As human thought ripened across centuries, something quiet and profound settled into awareness. A recognition that the cosmos was not merely a place they lived in, but a story they carried. Each generation inherited not just land and language, but a strange, luminous burden. The sense that consciousness itself was made of echoes. Echoes of supernova winds, echoes of ancient seas, echoes of forgotten continents and vanished creatures whose simplicity had once held the first murmurs of life. To think was to inherit the entire procession of existence, layered so subtly within the mind that it felt like intuition rather than history. Humans began to build instruments capable of touching the edges of the invisible. They extended their senses beyond the human body, listening to the hum of atoms, watching the dance of galaxies, measuring the faint background glow left from the birth of time. Through these instruments, the universe revealed itself not as emptiness, but as memory vast, intricate, unfinished. It showed humans that the elements in their bones had survived cataclysms beyond imagining, that the energy firing between their neurons once illuminated the cores of ancient suns, that their ability to wonder had roots deeper than the earth itself. And yet, the closer they came to understanding, the more they sensed that understanding was not the destination. The cosmos did not ask to be solved. It asked to be witnessed, to be reflected, to be remembered. Humans reached this realization slowly, like the way dawn reaches the tallest branches before the ground below. Awareness softened into humility, then into awe, a kind of reverence for mysteries too large to hold yet too familiar to ignore. Civilizations rose and faded, each carrying a different interpretation of the stars, as gods, as guides, as questions, as home. But across all eras, one truth remained constant. The act of turning the mind toward the sky changed the one who looked. It pulled thought outward, stretching consciousness across unimaginable distances, reminding every observer that the universe was not something separate. It was kin. Even in moments of silence, standing beside a river at dusk, feeling the cool air gather around the skin, listening to the first stars flicker into view, humans sensed that they were participating in something ancient. They felt an ache they could never name, as though remembering a story they had lived long ago but forgotten in the centuries since. This ache was not longing, it was recognition, a quiet understanding that the light traveling across the sky was older than memory, yet intimate as breath. As humanity's knowledge deepened, so did its questions. Scientists traced the origins of elements, mapped the evolution of galaxies, described the physics of life emerging from chemistry. But beneath the equations, beneath the observations, something softer persisted. The realization that, for billions of years, the universe had been preparing the conditions for awareness. That every collapsing star, every drifting molecule, every gentle extinction had been part of a vast unfolding that allowed minds to exist at all. Awareness, then, was not an accident. It was a continuation, a new arrangement of old forces, a new way for the cosmos to listen to itself. Through human perception, the universe gained a vantage point it had never possessed before, the ability to consider its own history, its own fragility, its own beauty. Humans became mirrors not only of starlight, but of meaning. And in this mirroring, the oldest question, older than language, older than species, rose again, gaining clarity through every generation that pondered it. It was the question that began in chemistry, that echoed through early oceans, that drifted with the first living forms, that deepened as intelligence took shape. What does it mean for the universe to remember? Humans traced this question into philosophy, into science, into art, into prayer. They discovered fragments of answers, hints scattered across disciplines like shells along a shoreline. But they also discovered that the most profound truths could not be held fully in the hands of reason. They had to be sensed slowly, like entering a quiet room after years spent outside. In quiet moments, humans realized that remembering was not merely storing the past, it was participating in it, through memory, through awareness, through imagination, They allowed ancient stardust to experience itself anew. The cosmos looked inward and found thought. Thought looked outward and found the cosmos. The loop completed itself gently, without triumph, without finality, simply by being. And as this understanding settled, softly, into the collective mind of humanity, a final resonance emerged. Not an answer, but an echo, a return to the question that hovered at the edge of all inquiry, shaping every whisper of curiosity that life had ever produced. What if Earth once knew something and forgot? The question lingered like mist above still water, neither solved nor diminished. For in the arc of existence, forgetting was not failure. It was space. It was openness. It was the pause that allowed new understanding to form. Earth had forgotten many things. Extinct creatures, vanished continents, ancient chemistries that once shaped the world. But through human minds, some of these forgotten truths surfaced again, not as facts, but as wonder, as reflection, as awe. And in that awe, the stars recognized themselves. They remembered, not through light, not through fire, but through us, their quiet descendants, breathing, thinking, softly returning the universe to itself. The story did not end. It simply faded, like starlight settling into dawn, like a question exhaled into the dark, waiting for another mind, in another age, to hear it again.